This conference will now be
So,
recorded.
Vishnu, are you going to send us the recordings as well? Finally.
Yeah. Once this is done. So
Oh,
I'm gonna place everyone on mute, guys. I'm gonna place everyone on mute. So one moment. Even I don't know how. So okay, that's all right. So please be on mute, guys. So let's start here. So what is sequential IO and what is random access, random IO? So I'm going to start with the very basics here. So please make sure you be very patient and attentive for the first 15 minutes. Then you'll get to see things going on. Things I'll basically move it very fast. So when you are reading data from the disk, when you are reading data from the disk, if you are basically reading the blocks that are adjacent to one another, so each subsequent IO request basically ends up reading this subsequent block which is stored adjacent to the adjacent key. If it is stored adjacently on the blocks, then the IO becomes the sequential IO. Sequential IO is also called as this streaming IO or stream IO. Usually the sequential IO is way faster, way faster. So I'm talking in the context of hard disks. So the random IO is when you are reading the blocks which are not stored adjacent to one another, and the block location can be different, and the time it takes to read a block depends on various factors. Depends on various factors. So I'm going to start explaining now in a different, in a more detailed context so that you get to understand things. So consider this as your hard disk is typical hard disk. So this is how your hard disk actually looks like. So here, this is what you call as actuator arm and the actuator arm. This is what you call actuator arm, and this is the read write head. Read write head. This is the head. This is the part which actually reads the data from the disk and even writes the data into a disk. Suppose say if I am making sequential IO. In this case, due to the fact that the blocks are stored adjacently to one another, my disk actuator arm does not have to move. Due to the fact that the subsequent blocks are stored physically next to one another, my disk actuator arm will not actually move, guys, will not actually move. It's the disk which, you have to understand even the disk rotates. So even the disk rotates. So the disk rotation, usually you will have 15,000 RPM. In your production environments, your disks are usually 15,000 RPM disks. So when you are making sequential IO, your disk actuator arm will not move. So here, in these cases, the elapsed times or the average read times actually are very less. So due to the fact that the blocks are stored adjacent to one another, and due to the fact that this read write head does not have to move a lot, you will end up reading blocks as fast as possible. But when it comes to the random IO, suppose say the first block, if I am trying to read this block and the subsequent read request, suppose say I'm trying to read a block that is present here. So in this case, my disk actuator arm has to move from, suppose say this is my initial block and the next subsequent read request is here. In this case, my disk actuator arm has to move till here, guys. And moreover, you also have to understand that what if by the time the disk actuator arm moves here and the disk position has already gone, then in that case, your disk controller has to wait until the disk completes the entire revolution. This is called seek time delay. Seek time delay. So you need to understand one thing. Random IO, when it comes to hard disks, are very expensive, very expensive. You need to avoid hard disk as much as possible when you are dealing with OLTP environments. Because in an OLTP environments, most of your scans are basically nested loops and index related scans only. You will have mostly 99% of the time in a pure OLTP database, you will have index scans and nested loop related joins only. Here, due to the fact that each IO that you make is mostly random in nature. If you are using hard disks, then things can get real slow. Things can become really slow because your read write head or the actuator arm has to move up and down continuously due to the fact that the blocks are stored at various locations. There is a significant amount of delay. So on an average, every hard disk provider gives 4 milliseconds space. They give a threshold of 4 milliseconds when it comes to accessing a particular block on the disk. So these 4 milliseconds, if you are making more random IO, and if your blocks are stored at very farther locations, this 4 milliseconds adds up insanely, and your query elapsed times decreases considerably. So you need to understand it. For random IO, so for OLTP applications, always goes with SSD. So I'll talk about why I recommend SSDs and hard disks for certain set of workloads. You will understand it in the next set of slides. So for now, remember that hard disks tend to be very bad. Where there are many websites which say, go with the RAID 5, RAID 10, everything. But honestly speaking, a hard disk provides you a maximum of, suppose, say 200 to 500 IOPS only. So if you even configure RAID, suppose say I configured RAID 10 with suppose RAID 10 or RAID 0. Suppose, and the best case scenario, considering that the RAID I'm using is 0. In this case, actual amount of IOPS, suppose I have 10 disks, I would end up with only 5,000 IOPS. But you need to remember that a single SSD or a solid state disk itself can give you close to 96,000 IOPS. Enterprise level SSDs can give you insane amount of IOPS. So you need to remember this case. So SSDs are way faster. And here, due to the fact that you have a moving part in your hard disk, things tend to fail as well. So you need to remember that. So the hard disks tend to fail more if you are making more random IO. So we have seen disks fail every week, even though the hard disk is brand new. Due to the fact that we are making more random IO, the disks actually failed more often. So let me go to the next slide. So every disk you have, every disk, regardless of whether if it is a SSD or a typical hard disk or even an NVMe flash. So yes, SSDs are of two types. Case one, they are basically, uh, the type of SSD is basically the interface used to connect to the server. So you can have SAS interface or even PCIe interface as well. So the SAS interface, these SSDs with SAS interface will give you less IOPS. PCIe SSDs will give you more IOPS. So usually the maximum IOPS I have seen here is only 95K IOPS for a SAS interface SSD, but for a PCIe SSD, you can see somewhere close to 256K to somewhere even around 600K IOPS, 6 lakhs IOPS as well. So remember that PCIe SSDs are way more faster than SAS interface SSDs. So, and let me proceed ahead. Every disk, regardless of whether if it is a hard disk or an SSD, the manufacturer gives two sets of thresholds, guys. Two thresholds. So the threshold related to IOPS and the threshold related to bandwidth as well. As soon as one of these IOPS, either the IOPS or the bandwidth, hits 100%, your disk utilization reaches 100%. So let me just show you a small example and then we'll proceed ahead. So I'm going to start a VM here. I'm going to start a VM, and this VM is on a hard disk. So I'm going to run a workload here. Let's see. So first thing what I'm going to do is I'm going to start. So one moment.
Can I increase the font, Vishnu?
Yeah, no. This is a small thing. This is not required. I mean, this is on a VM. I just need to see. That's it. Give me a minute here. I'm just starting up the database. That's it, nothing else.
Vishnu, can you write when you write? Can you write maybe a bit in the middle or on the top, because I'm not able to see the lower part.
Oh, really?
Yeah, I'm not sure
Okay.
about others. I mean, but
Yeah, I think probably it has to do with the what do you call your I mean your resolution. So let me try to do that.
It's fine for me.
So now I'm going to start a small workload. Yes, I'm going to start a small workload. So okay, I'm going to start a small workload. Give me a minute here. So I'm going to start a workload that actually makes index scans. So index scans are mostly random reads, guys. So let me just show you that as well. So I'm running the workload. One moment. So I think this is more than enough. So I'm going to minimize this thing. So I'm going to open up a terminal session. I'm going to show you the SAR output as well, and in a different window. I'm going to show you the IOGOTOF command as well, so that you get to see the total bandwidth used and also the IOPS as well. So let me just start the workload now. I'm basically making index related scans case. So can you see the maximum amount of data read? Everyone, can you see it?
Yes, we can see that.
So I am hardly making 4 MB per second. I am hardly reading 4 MB per second. But if you notice, I am hitting the cap on the IOPS. I am basically hitting the cap on the IOPS. So every manufacturer gives 2 sets of thresholds for your disk, guys, for your hard disk. So you have an threshold on bandwidth, maximum amount of data that can be read, the maximum amount of data in either MBs or gigabytes. So you can read in a second, or you have a bandwidth, you have a threshold on IOPS as well. Here, due to the fact that I am making index related scans, my bandwidth is very less. I mean, the bandwidth utilization is very less. But in fact, I am hitting the cap on the IOPS. So right now, what I'm going to do now is I'm going to run a different workload here. So I'm going to show you the other workload as well. So what I'm going to do is I'm going to run a full table scan workload. So once this is done, I'm going to run a scan on the full table scan as well. So in the meanwhile, let me just show you.
So Vishnu, what do you have on the small screen at the top? What is it?
I cannot hear you.
What you have in the
Can
small
you ping?
screen?
I mean, instead of
Is that a stop command or what you have in the small screen?
That IO topics.
Hey, can you ping? Can you ping, guys? I mean, there was more noise, so that's the reason. Can you ping? So it's the IO top command. So the next workload, what I'm going to do is instead of going with the index scans, I'm going to run a load that actually performs the full table scan on the database. So now let's see in terms of bandwidth and the IOPS. Can you see here, guys? Everyone? The bandwidth, I am basically hitting the cap on the bandwidth. I am hitting the cap on the bandwidth. But when you look at the IOPS, I am consuming only few IOPS, guys. I am consuming only few IOPS. So let me just stop this, take the screenshot of this, and then try to explain. So this is when I was making full table scans here. So I'll try to explain things more precisely. First, for now, please understand the relationship between IOPS and the bandwidth. So this is very important when you are dealing with certain workload. So let me just take a screenshot here. So here, I'm going to run the workload again so that sudo IO top command will give me the actual disk read and write information as well, how much amount of data I'm reading or writing per second. So I'm just taking a screenshot here. This is when I was making full table scans. Now, subsequently, I'm going to start a workload on the database wherein I end up making index related scans. So let me just run that as well. So give me a minute. It's still doing the scans. So instead, I'll let it finish. So what I did here is I basically stopped my application. So here from the Java perspective, I did stop the workload, but you need to understand that even though the application is stopped, sometimes the sessions will not go immediately. So until the SQL statement is executed, sometimes things will not proceed ahead. So what I'm going to do now is I'm going to run a scan. I'm going to make an index scan case where all the SQL statements end up doing index range scans only. So I'm going to show you the plan as well. So I'm making the index range scans here. So since this is a hard disk, I mean things are pretty slow. That's all right. In the meanwhile, let me just take a screenshot of this as well. Can you notice here? This is an index range scan. So all the SQL statements ended up making index range scans only. So you need to understand one thing. When your application is OLTP application, if your application is an OLTP application, then you are more, due to the fact that you are more likely to perform single block reads or basically perform index related probes. The aggregate bandwidth that you utilize tends to be very less. Here, in fact, what happened was due to the fact that I was doing full table scans, I am more likely to saturate the bandwidth. I am more likely to saturate the bandwidth. You have to remember. So don't just think that, so my hard disk provider, hard disk vendor gave me 200 Mbps bandwidth, but in fact, I'm reading only 3 Mbps. Even then, the disks are 100% utilized. This is because you are hitting the cap on the IOPS here. You are hitting the cap on the IOPS. Even though when I was making full table scans, even though I am making only 50% of my IOPS, the disk utilization rate became 100% due to the fact that I am saturating or hitting the cap on the bandwidth. So an important relationship here, as soon as you hit the cap on either the bandwidth or IOPS, your disk utilization rate hits 100% and your subsequent IO requests are queued. So eventually what happens is that average response times increases. Average response times increases as soon as you hit a cap on either IOPS or bandwidth. So most of the DBAs actually look at the average wait times. So when you're looking at, suppose say you generate an AWR report, you end up seeing DB file sequential read wait event as one of your top wait events. You see the average wait time. Suppose say here it is more than 20 milliseconds. You draw a conclusion saying that the storage, something is bad, or you have a failed disk or something like that. This is wrong approach altogether. This is completely wrong. As soon as you hit the cap on either the IOPS or the bandwidth, your average wait times actually increase. Don't just run these utilities and then, look at the average wait times and think that the underlying storage is bad. So many times over the course, if you are suppose a 7 years experience or whatever it is, so if you would have raised many tickets to the storage team thinking that the underlying storage there might be some problem, but eventually you will end up getting a reply from the storage team saying that things are absolutely perfect. There are no failed trace or nothing. The load on the server is load from your side is very high. You have to understand it. So it can be hard disks, it can be SSDs, whatever the technology that you are using. You have two types of thresholds or thresholds. One is related to the IOPS and another is related to the bandwidth. As soon as you hit any of these thresholds, disk utilization rate hits 100% and all the eventual IO requests gets queued and the average wait times increase. Average wait times increase. So now, when should you consider IOPS and when you should consider bandwidth? So you need to understand one thing is a database standard block size is 8 KB. Suppose if I read 100 blocks a second or 1000 blocks a second, or I'm making 1000 IOs per second, due to the fact that each database block size is only 8 KB, I end up reading only 8,000 KB only. So 8 MB per second is more than enough to saturate my bandwidth. Sorry, IOPS. So if I'm reading in an OLTP database, so I'll put it in a different sense so that you get a clear picture. My storage subsystem provides, suppose say 1000 IOPS. Due to the fact that your database block size is 8 KB, even though you read 1000 blocks in one IO 1000 blocks in 1 second, the maximum you will be reading is only close to 7.8 or 8 MB only. Even though you are reading 8 MB, due to the fact that you are making small IOs, each IO of the size 8192 bytes or 8 KB, you are more likely to saturate the IOPS. In an OLTP environment, IOPS are pretty important. IOPS are pretty important. If you do not have enough IOPS, your elapsed times or the maximum throughput that you can achieve reduces significantly. You need to have more IOPS. The priority when you are designing a database or when you are migrating a database, OLTP database, the preference should be given to the IOPS only, not the bandwidth, not bandwidth. So bandwidth, you are more likely to consume IOPS only in your OLTP environments, not bandwidth. And suppose say I am making a full table scan, I am performing a full table scan. You have to understand that while performing the full table scan, Oracle reads multiple blocks in one IO operation. So here you will eventually make large IOs, large IOs. Due to the fact that you are making large IOs, per bandwidth actually saturates way more quickly than your IOPS. So even before you hit the cap on the IOPS, you are more likely to hit the cap on the bandwidth. So when you are dealing with OLTP database, give more weight to the IOPS. And if you are dealing with warehouses, give more weight or preference to the bandwidth. So you need to remember these things, please. So when you're working on warehouses, most of your queries usually end up with hash joins, full table scans only, most of the time. So here, in a warehouse environment, you are more likely to consume the bandwidth, not saturate the bandwidth, not the IOPS. Hard disks will give you very few IOPS. Don't, I mean, historically, people have been using hard disks for quite some time. So I'll put it in a different sense. The hard disks have been there for very longer time. SSDs are, I mean, only for the past decade, or I'll put it in a different sense, only starting 2005, I believe. So the SSDs are, I mean, the people started using SSDs before 2005. Every storage was basically on hard disk only. All the enterprise level storage they used were basically hard disks only. So hard disks will provide you very less IOPS. Even if you have 30 disks, even if each disk provides you 100 IOPS, you would end up maximum getting only 3,000 IOPS only. 3,000 IOPS in terms of bandwidth for an OLTP workload. As soon as you hit 24 MB per second, approximately, you end up saturating the IOPS. So you have to be very cautious when you are dealing with OLTP environments. So typically, even a small consumer grade SSD will give you somewhere between 40K to 40K to 98K IOPS space. SSDs will give you hell lot of IOPS. So these are way more beneficial, and moreover, due to the fact that the hard disks have moving parts, so they tend to fail as well. They tend to fail more frequently if you have more random IOs as well. So you need to remember that. So this is the relationship between the IOPS and the bandwidth. So we'll now proceed ahead with the actual Oracle full table scan related fundamentals case. And moreover, there are two ways you can make an IO. So there are two ways with which you can make an IO request. It can be either a synchronous IO request or it can be an asynchronous IO request as well. So synchronous is when, suppose say a process initiates an IO request until the time the block is read from the disk. This process will be blocked or it waits till the corresponding IO request is complete. So you end up waiting till the time that particular block is read into the memory or into the process buffers as well, whatever it is. So in an Oracle database, if you are reading a block, you would end up bringing it into the buffer cache or even into your PGA. So you have to remember, if you are making use of synchronous IO, your process will end up waiting more frequently. Asynchronous IO is when you have to understand one pretty important fact here. Suppose, say, I have 3 blocks present at various random locations on my disk. If I am making use of synchronous IO, I need to wait till each block is read before issuing another block read. Unless this block is read, I cannot proceed ahead. So I have to wait until the block is read. Then I have to make an IO request. And until this block is read, I cannot proceed ahead on the given IO. So issue an IO. So you need to remember that suppose say I have to read 100 blocks which are located at random locations, then I end up making 100 IO calls. And moreover, for each IO call, I have to wait until that block is read. So the synchronous IO is way worst when it comes to OLTP workloads. So you have to make sure that you use asynchronous IO more frequent. Asynchronous IO. So I'll talk about the file system IO options and everything, all the initialization parameters that actually correspond to this in the next subsequent slides. So asynchronous IO is when your thread or the process. So you make an IO request. Instead of waiting for this block to be read, you proceed ahead. You do other activities. After a certain period, you go back and see whether the block is read or not. So here, due to the fact that the thread does not wait till the IO operation is complete, so things can, there are too many benefits here, guys. Suppose say, if I have to read 100 blocks, which are stored at random locations, I can initiate a single IO request to read all these 100 blocks and then proceed ahead with my activity, proceed ahead. So in the meanwhile, I can issue another IO request, or I can process the data that is read from my previous request as well. So asynchronous IO is way better than synchronous IO. Your thread will not end up waiting unnecessarily. And moreover, you have to remember that asynchronous IO is supported on all the platforms now. So don't, there are several blogs now, websites and everything. They say that, the OS should also support asynchronous IO. This is all legacy stuff, guys. I would put it in a different sense. These are ancient data. So every major operating system right now supports asynchronous IO calls. So let me just proceed ahead. So
Vishnu,
I'm going to do one.
how IOPS is different from throughput?
Throughput in the sense, what throughput you're talking about?
Like IOPS is like, okay, at times the throughput of the data reaches its threshold. Like in
Throughput
context
of the data. So I don't get it. So
no,
are you
in
talking
context
about throughput in terms of bandwidth,
no,
or
in
in which
context
context?
like we have the databases hosted on cloud, so
Okay.
IOPS and the throughput are the like major components in performance bottleneck. So at times
IOPS and
IOPS are
bandwidth.
at times the IOPS are way low, but the throughputs are like gone crazy. Like we get to hear from the AWS executives, and then yeah, they suggest to improvise the instance types.
So the throughput, whatever you're talking about, are you talking about from the bandwidth storage layer throughput, or network level throughput, or what is it precisely?
Yeah, network level. How much
Network
data?
layer is different. This is, I'll put it in a different sense. So if you are able to make 10,000 IOPS, okay,
Hmm?
for an OLTP database, if you are making 10,000 IO operations per second, so let me show you in terms of bandwidth. You get to see the clear picture. So 10,000, 8192 by 1024 KB, you are hardly reading 78 MB per second. So your cloud providers usually give a minimum of 1.5 gigs network interface space. 1.5 gigs in the sense 1024 star 1.5. So this is MB per second. So you can buy 8. So the total bandwidth you can get out of it is 192. So can you see you are not even reaching at least half. Can you see here?
Yep.
Yeah, this is what. So don't get confused with the terms, the throughput and everything. It's pure, simple math here. I'm not doing any James Bond related stuff, just the simple math, wherein I'm showing you. So for an OLTP application, if you are more likely to make random IOs only. I'll talk about why random IOs. So yeah, you will get to understand more of these things when I'm talking about indexes. So we are talking about full table scans only now. We are only talking about full table scans. So let's talk about full table scans first. Then we'll talk about indexes. Therein I'll show you precisely what calls everything are used as well. So synchronous IO, guys, coming back.
So
Synchronous
Vishnu,
IO.
I have one question. Can I ask, or shall I wait for session to end?
Yeah, ask.
Okay, so let's say I have a system which is designed to serve something like 3,000 or 4,000 IOPS, and through workload I'm requesting something like 10,000, 15,000 IOPS. So how does that situation this hardware handles it? I mean, I know, it slows down the operations. We see a lot of performance issues, but how the systems are designed to handle this kind of situation when
So I'll
something
put it in a
enters
different sense. I'll show you a practical example so that everyone can understand as well. So I have storage here. I have a table here. So what is the table size? 1.2 gigs, right? Can you see here?
Yeah, right.
So I have another disk here. So let me just start up the instance. I believe I have data there. If I don't, I'll start loading. I mean, anyhow, it's provisioned on NVMe, so I don't have to worry about the IOPS here. So let me show you. So I don't have any table here. Let me just quickly load the data. So you can use the same program what I'm using there. So let me just try loading 1 gig of data. So don't think that it will take ages. So finally, I have to change my connection string as well. So 1.20. Okay, now I'm going to start loading the data into this particular table. So let me just show you. 6 size. So I have already loaded almost 1 gig of data. So yes, create index mark 4 underscore IDX and students of mark 4. So I'm going to use the same workload. I'm going to use on both the databases. I'm going to go with the same workload on the same SQL statement as well. Let's see the throughput in terms of executions per second that I achieve. Select a dot run board. So I'm using 10 threads to basically run the workload. Okay? So I'm going to show you what they're doing as well. So here, what? So can you notice the plan? Am I doing an index main scan? Now, let's see in terms of disk level. How many TPS I'm making?
No, 33 GB or MB?
33,000 IOPS.
Yeah.
So in terms of bandwidth, let me show you the bandwidth as well. How much I'm making? Hardly 260 Mbps, isn't it? So let's see in a different context now altogether. So let's see in terms of executions per second that I am getting for this particular SQL statement. So automatic. Can you please, everyone, please place your calls on mute, please. I don't want to do that. Shabir.
Yeah.
So can you please place your call on mute?
Oh, sure. Okay, one second.
So can you see here, I am hardly getting 20 executions per second, isn't it? Everyone, can you notice? 20 to 30,
Yes.
right? 20 executions per second, and how many IOPS I am consuming? So close to 33K. So I'm going to start the same load on a database which has a maximum IOPS cap of, on a virtual machine that is residing on a hard disk. So I'm going to do that. So now let me start the same workload here, and let me close away all these sessions. So exit Aura H will connect me to my hard disk. SAR-D1 Aura H sudo iota. Let's see in terms of bandwidth is. So IOPS, how many IOPS is? Maximum 400, isn't it?
Right.
I'm reading only 3 MB per second. So this is okay. Now let's look at in terms of executions per second. Will I be able to get at least 20 executions per second? So it's taking time, yes. So it's due to the fact that I'm pushing the limits of my disk and things are not good. So did I get even 30 executions? It's not even increasing. Man. Can you notice everyone? Now 31,
Yes.
33, 38. See, I'm not even getting subsequent. The throughput in terms of so for any application, the SQL executions per second is very important. So if your database cannot give you sufficient executions, sufficient calls, applications calls. So suppose say if my application is calling a particular API, which executes a SQL statement. Suppose say I'll put it in application terms so that you get to clearly understand. Application terms, they say that, I'm trying to call 2000 APIs per second. But here, the SQL statements, if you are executing one SQL statement in a second, how long will it take to complete these things? Don't you think that here, due to the fact that you don't have sufficient IOPS, aren't you basically reducing the throughput of your application altogether? You need to understand one important thing here. The database is just a back end. For any business, they don't actually consider which database you are using. So as long as the data store that you are using gives you the sufficient executions per second or sufficient TPS transactions per second, they are more than happy. So you need to understand that. So the application level throughput is what drives your business, not your database. So here you need to basically provision your IOPS more carefully when it comes to an OLTP database. If you do not provision your IOPS, things will get screwed altogether. See, I have shown you in an NVMe storage wherein I was making close to 35K IOPS. And hardly I'm reading only for 200 to 250 MB per second. So you need to understand that. So you need to have sufficient IOPS. So did that actually answer your this one? Query?
Yes, yes, Vishnu.
Vishnu, I will add up to the same question. Suppose we have the storage on a logical volume and all those are in a network. So
Okay.
they we will be having in when we are coming from the logical volumes. So the disks are striped from the OS. On top of it, if we come up with some ASM, so again further striped. So
Okay.
when we do this IOPS, so this is scattered across the disk. So
Yeah, regardless.
so
Yes.
yes, it is across the disk. So how can we say my
Uh-huh.
IOPS and the bandwidth and the network throughput would really causing the performance issue? Because
So you should talk to your developer. You should talk to your storage team first. How much IOPS they are provisioning. You should always talk to your storage team first. So IOPS from the server level you cannot identify. As a DBA, you cannot identify. The Orion tool, all these are bullshit tools. So I'll put it in a different sense. The actual IOPS provided by the storage subsystem, you cannot identify it unless you talk to your storage admins only.
whereas network is also there, right? So from my database server to the storage server, there is a network link
Yeah.
and how many hops it will be
Yes.
there, and then that also matters in between. So if that is the case,
Yes.
this IOPS and the bandwidth, sometimes it would fail considering these two things. If my performance issue is, I'm facing a
So
performance issue and seeing
the
good
I get
amount of
it. I get
IOPS.
it where you're
Yeah,
talking. No, I
yeah.
get what you're talking about. So this comes especially in the picture if you have shared storage.
Yes.
If your storage server is shared across multiple servers. So you need to talk to your storage team to make sure they guarantee certain number of IOPS provided to your machine directly. They can do that. They can do that. They can basically set a limit on IOPS. So usually I'll talk about over provisioning, all those things later on, guys. Not now. This is not the time. We are just talking about full table scans. We haven't even talked about index scans, right? So I'll show you even how to even control that IOPS system. So slowly, not now. Hope you don't mind.
Got you. No, I
So
understand.
we are now we are actually going sidetracked here. So hope you don't mind. So you need to understand one thing is everyone. Though, how do you identify whether a process is making synchronous IO or asynchronous IO? How do you identify that? So let me just show you a small example and then we'll proceed ahead. So I'm going to use the same storage here. So practice SST. So what I'm going to do is, so one moment guys, let me stop the workload and everything. And let me stop the workload and I'm going to force restart this particular machine. Go ahead, restart. So, okay, this restarted. So I'm just rebooting the host altogether because I don't want that full table scan to complete the two due to the fact that my storage is on a hard disk. It takes ages to complete it. So that's why I'm just trying to reset my virtual machine. So now let me show you in terms of IO calls made, guys. So when you have your file system IO option set to none by default, you will end up by default when you create a database. When you create a database, by default, file system IO options parameter will be set to none. In this case, Oracle always uses synchronous IO. There is no scope for asynchronous IO. So your server process, log writer, database writer, everything uses synchronous IO only. Synchronous IO takes ages due to the fact that you have to wait till the current block is read. So you cannot proceed ahead. Let me just show you that in practice so you get to see things more clearly. So I don't want even the hard disk here. So I'll go with the NVMe with this. Alter system set, file system, IO options set to none. Scope is equal to ST4. I'm going to restart this particular database here. In a different session, what I'm going to do is I'm going to run an strace on the process case, so that you get to see what IO calls I am actually making. So this is my SPID, strace-p. Yes, I have attached to that particular process self TVG of mark1 from students, where mark 4 is equal to 1, 2, 3. Can you see here this? Can you see the read calls? Everyone? Hello?
Yes. Yes, yes, we can.
Yes.
So
Yes, absolutely.
how do you identify which data file I am reading? So here you have this call, particular call. How do you actually identify which data file I am reading from? So the first one is nothing but the file descriptor base, file descriptor. So this is my SPID. All I have to do is work FD. Can you see the 259 file number? Everyone? This is the user's data file. I'm reading the data from the user's data file. So all these IO requests are to the user's data file only. So when I am making use of synchronous IO, you need to remember one thing. You need to remember one thing here. Until unless, so suppose let me take this particular read for example. Until unless the process finishes or brings this particular block into the buffer cache, it cannot initiate another IO request. The synchronous IO is way slow, guys, way slow. You end up making individual IO requests for each block, be it an index block or a table block. So while performing an index range scan or index unique scan or index skip scan, whatever it is, if you are probing the table using an index, when you are using synchronous IO or file system IO option set to none, by default, you would end up using synchronous IO. So you cannot proceed ahead by reading in another block until unless the current IO request is complete. So this is very slow. Due to the fact that the process is blocked till the complete IO request is complete, and moreover, it is at the mercy of your storage as well. Due to the fact, I mean, you end up initiating. So I'll put it even in the simplest terms so that you can understand. Process A makes an IO request to read a single block into your buffer cache. Now, until this block is read, I cannot proceed ahead to make another IO request. I have to wait until this block is read. Suppose say this block is present on a disk whose average wait times are suppose say 100 milliseconds. I have to wait 100 milliseconds before I have to wait 100 milliseconds, and then once this block is read, then only I can proceed ahead by reading a different block. So you need to remember this. So now let
Vishnu,
me just show you.
Sorry to interrupt. Yeah, in that screen, right, you are showing different, synchronous IOs happening, right? So all of them are waiting. I mean, so the first one waits till the second one starts only after the first one completes, right? I mean,
yeah, first one is complete.
that one
Yes.
is
Yes.
okay.
Yes.
Sequence IOs, it's doing okay.
So it's not sequential IO. You are not understanding things properly. I am making an index scan. All these blocks are present at random locations on my disk here.
I mean, I was trying to refer as synchronous, actually. Yeah. Not
Yeah, synchronous IO only. Synchronous IO only. So you need to understand one thing. If you notice these calls, pread 64 or even readme or pread, all these IO calls are basically synchronous calls, guys. My process has to mandatorily wait until this IO request is complete. I have to mandatorily wait. Synchronous IO when it comes to OLTP workloads is deadly. So there are many people who suggest don't use asynchronous IO. That is way history, guys. That is history. I mean, they say that you can end up with corruptions. Yes, you can end up with corruptions. Yes, we go in a flight, yes, the flight can crash. But how frequently? Very rarely. I mean, 99.9% of the people, or even 99.9% of the time, I mean, the flight won't crash. So you need to understand asynchronous IO. If you believe that asynchronous IO can end up with corruptions, yes, it will end up with corruptions. But due to the fact that most of the bugs are actually resolved, and the APIs are way more sophisticated these days, so the chances for you to encounter corruption is way less, very less, considering the benefits that I get. Considering the benefits that I get using the asynchronous IO, these benefits outweigh the disadvantages when it comes to the corruption. So let me just show you a small example here. So you have to remember all these calls are synchronous calls. Even pwrite 64 is also a synchronous call. So let me just show you in a different sense here. So if your file system IO options is set to none, by default, you will end up making synchronous IO calls only. Synchronous IO calls only. So now I'm going to show a different way. I'm going to run a different scan list. So what I'm going to do is I'm going to make use of a full table scan list. Select AVG of mark1 from students. So this query eventually will make a full table scan. So let's see in terms of read requests. So you have to understand one thing here. While performing a full table scan, let me just take a screenshot of it and paste it here. Can you notice the amount of IO I'm making, guys? Everyone, I am making 1 MB read here, 1 MB. So the value specified here is in bytes. So let me just take a calculator here. By 1024 is KB, and then finally 1 MB. So I'll put it even in a different sense. So this is show parameter db file multi-block read count. So what am I doing here? My database block size is 8 KB, and due to the fact that db file multi-block read count value is 128, I am reading 128 blocks in a single IO operation, which translates to 1 MB. So I am basically making a single IO request which reads 1 MB data in a single call. So I am reading 1 MB in a single call itself. So people usually think that 128 blocks will be read, but yes, 128 blocks will be read using a single IO request. You have to understand that in an extent, while making a full table scan, you read all the blocks that are stored adjacent to one another. Due to the fact that the data blocks are stored adjacent to one another, instead of reading each block at a time, I can end up making a large IO, reading multiple blocks in a single IO operation. So even though I'm making synchronous call while performing a full table scan, due to the fact that my DB file multi-block read count here is set to 128, I end up reading 1 MB of data in single IO operation. So don't assume that Oracle will always read one database block at a time. It depends on whether you are making an index range scan or full table scan, index related probe or a full table scan. While performing a full table scan, you will end up making large IOs. Due to the fact that you are making large IOs, your bandwidth tend to saturate more quickly than your TPS. Sorry, IOPS. Due to the fact that I'm making large IO requests, I would end up saturating or utilizing more bandwidth than IOPS. Each IO request, I am reading 1 MB of data. So I'm going to do one thing. I'll show you the same thing with a full table scan on a NVMe disk so that you get to literally see. So I'm going to run this now. 20 on an SSD. So I'm going to run this particular load now. Let me show you in terms of IOPS and bandwidth as well. So Control C, sudo IO top. So isn't it basically shocking, guys? So I'll put it in a different sense. I am basically making direct path read here. I am reading the data from the data. I'm making a full table scan here. I'm making a full table scan, but the IO level, but at the IO layer, I'm not seeing even a single block. I mean, can you notice here? So, and I'll also show you the SAR output as well. SAR-D1. So, isn't it surprising, guys, everyone? So even though I am making a full table scan, why am I not reading even a single block from the disk? So the first batch guys and then the subsequent second batch guys, please don't answer. So I am making a full table scan here. All my 10 sessions are making full table scans, are performing full table scans. But why am I not reading even a single block from the disk? Direct path read means that you are reading the data directly from the disk itself into your PGA. So there you are not even reading the blocks from your buffer cache. You are reading the data from the disk only. So in this case, so isn't it surprising, right? Ever come across this particular scenario? Everyone?
Yes, we have seen that.
Yeah.
Yes, Vishnu.
Yes.
So can you come up with a reason why? I don't see even a single block read from the disk using SAR output or even sudo IOTA. So it is due to the fact they are present in the file system buffers. So regardless of the IO type, regardless of whether you are reading the table data using a full table scan or an index range scan or whatever it is, if you are reading some data from the disk and if your file system IO options parameter is set to none, by default, these blocks will be stored in your page cache. Now, even though I am making an IO request, due to the fact that these blocks are cached in the page cache, my IO request is satisfied from the file system IO buffers or page cache itself. This is the reason why I am not even making even a single IO call. So let me just flush these file system buffers and let's see. Now can you see, guys? As soon as I flush the file system buffers, can you notice the reads, everyone?
Yes.
Yes.
So you need to understand that once you set file system by default, file system IO options is set to none. So in this case, every IO request you make, be it write or be it read, even the writes are cached into your page cache or the file system IO buffers. The file system IO buffers will also contain the dirty pages as well. So let me just set this file system IO options to set all now. So I don't want it to gracefully terminate and then start this. I'm just terminating it off. So I'm just stopping the workload for now. So once the database is started, I'm going to run the same workload here. So due to the fact now the file system IO options is set to set out, I would end up reading the data from the disk. Let's see how much amount of data I am reading here. How much amount of data I am reading per second, guys?
It's
60.
around 6 GB.
Yeah.
Yeah, around 6 gigabytes per second. I am basically reading the data from the disk only. So, I mean, it's not a bandwidth, guys. Bandwidth in the sense, it's not gigabits per second. It's basically gigabytes per second. I mean, the storage, I messed it a lot. I mean, I'm using the caching at my Mac level as well. So I'm ending up seeing too much bandwidth. So now I'm going to show you how the IO calls actually look like when I'm basically performing a asynchronous IO. So I'm going to perform a both full table scan and an index range scan as well. So before that, let me flush everything out. And moreover, let me stop the workload that I'm running here as well. So I'm stopping the workload here as well. So now I don't have anything running on now. So I'm going to run an strace on this particular session. strace-p. Now what I'm going to do is I'm going to perform the full table scan. Can you see the IO call, guys, everyone? IO submit IO call is basically an asynchronous IO call. So you need to understand. Here, I am reading also in certain cases, I am reading 1 MB as well. So there are certain places wherein I'm reading few blocks. I'll try to explain this in the later section, but not right now. But you need to understand for now, an asynchronous IO call usually has IO submit here. So a process, when it is trying to make an asynchronous IO call, it makes use of IO submit call. So now let me flush everything out from my buffer cache and the shade pool. And so now I'm going to perform an index range scan here. Select AVG of Mark1 from students where Mark4 is equal to 1, 2, 3. Let's see the calls case. So you need to understand one thing here. When it comes to asynchronous IO, Oracle can batch reads related to multiple blocks in a single IO call. If you notice here, how many blocks am I reading, guys, everyone? I am reading close to 127 blocks in a single IO operation. I am reading 127 blocks in a single IO operation. Which blocks I am reading? So this is a single block. So comma, this is a single block. So I am batching reads of close to 127 blocks, which are stored at random locations in a single IO call. So when I am using asynchronous IO, due to the fact that I am basically requesting multiple block reads in a single IO operation, I end up exploiting the IOPS at the storage layer. I end up exploiting this IOPS at the storage layer. If I have sufficient IOPS at the storage layer, I can read multiple blocks in a single IO operation with very less elapsed time, or I'll put it in a different sense. So the disks are not 100% utilized. So I have enough, suppose say I have 1000 IOPS left on my storage layer. Now, if I make an IO request, suppose reading a single block takes 1 millisecond. Due to the fact that I'm issuing an IO submit call, I mean the asynchronous IO call, and thereby batching 127 block reads which are present in different locations, I end up reading 127, all these 127 blocks in 1 millisecond itself, guys. So can you notice, everyone? I am exploiting the IOPS at the storage layer. So due to the fact that I have enough IOPS at the storage layer, so, and moreover, as I am batching multiple block reads which are stored at different locations, these are the locations, guys. You can precisely identify where these blocks are also present. So you don't have to dig to that level, guys. It does not make sense. And moreover, it is not needed as well. You can see the offsets and everything. So here, once you make use of asynchronous IO, since you are batching multiple block reads in a single IO operation, you are exploiting IOPS in one way, and if you have sufficient IOPS, you end up reading all these 128 blocks in 1 millisecond itself. If I'm not using asynchronous IO, if each block read requires 1 millisecond, then this entire request or reading these 127 blocks will take me 127 milliseconds. So this is it regarding the IO calls case, synchronous
So
IO
this
calls, and
the 127 number is derived based on the DB file multi. That parameter, right, Vishnu?
so no, it has nothing to do with DB file multi-block read count. I am making, see here, I'll show you the SQL statement that I showed. I am making an index range scan. So I'll talk about this batching and everything later section, guys. It's not time now. I mean, we are not even talking about full tables. So once we reach that level, I mean, you will get to understand these things more precisely. Please be patient. I'll try
Yeah,
to
Vishnu.
explain as many things as.
Vishnu,
Yes?
one small thing, similarly, does that, file system IO options equal to direct IO also behave the same thing, because in our environment we are using that.
Yeah, direct IO in this case, you will make synchronous IO only. Synchronous IO is worst case. I mean,
So direct IO
I'll
is
put
okay.
direct IO is synchronous IO only.
It bypasses the.
Give me a minute.
Okay.
Direct IO, everything will talk.
You're talking okay later.
In the slide number 28.
Good, please.
We are only at the 6th slide. So please be patient. Please be patient. So you would end up seeing IO submit calls case. So these are the IO calls that a process makes when you are making an asynchronous IO. I mean, so my process does not have to wait until the IO is complete. I can end up performing other tasks as well. So the asynchronous IO is way more faster. After certain time, the process can come back to see whether the IO is complete or not using the IO get events call. So I made an IO request. After some time, Oracle or the server process can come back and see whether the read request is complete or not. Can you see here, everyone? IO get events actually means, I mean, I'm going back and then seeing whether if I ended up reading the block or not. So that is one thing you need to remember. So IO get events is basically like checking whether the actual IO request is complete or not. So you have to understand period 64. Period 64. So there are certain calls. Read, even these are synchronous calls only. Read we call is also a synchronous call. We'll talk about that read we call when we are talking about prefetching, or I will put it in a different sense. It's basically the buffer warm-up. I mean, even the most, very, even the experts actually think that it is prefetching hitting in, but it's not. So we'll talk about that in the when we're talking about indexes. So for now, since we are dealing only with the full table schemes, now this is where things actually start.
Vishnu, we can call then synchronous IO as deprecated.
It's not deprecated. Synchronous IO is still there. So I would recommend you guys to go with asynchronous IO only.
So does it affect anything on the application design part? So earlier we
No,
said
it has
go
nothing
by...
to do with the application.
Okay.
From the application side, it has nothing to do.
because of the application nature, we may get into the corruption of the database, something like basing on the
Yeah,
transaction.
I'll put it in a different sense. So the corruption, I'll put it in a different sense. So if your application, if you are able to provide, suppose say 10K transactions per second using asynchronous IO, or once you set the, I'll talk about that parameter more. So suppose say 10K IOPS or 10K transactions per second you are able to provide. But if you use synchronous IO, you end up giving only only 1K transactions per second. And here, due to the fact that you are using asynchronous IO, the chances are the corruption, I'll put it in a different sense, once a week. So fixing this single block corruption once a week is good, or you risking 90% of your transactions. What do you think, guys?
Yeah, second one is
So,
better.
yeah.
I mean, depends
So
on
from a business
also.
perspective, yeah, I'll put it in a different sense, even more, I'll elaborate. So the chances of corruption are pretty damn less, guys. While I was working in Amazon, I used to have close to 100K to 140K transactions per second. We used both. I mean, once you set the file system IO options to settle, Oracle can make use of either asynchronous IO or direct IO, depending upon, automatically it will choose. So you need to understand, even in those cases, we never encountered corruption. Yes, we will see corruption, that too, once a week, or not even once a week, once a month or something like that. The benefits that you get actually outweighs this thing. Suppose say if I am getting 1,000 transactions per second using synchronous IO, using an asynchronous IO, I am suppose say getting 10,000 transactions per second. Here, I may suppose say each transaction worth is $9. I am getting a revenue of $90,000 a second. Which one do you think is more suitable for the business, guys?
Which get more dollars.
Yeah, that
Yeah,
makes sense.
that is it.
Understand.
So corruption, yeah, you should deal with it as part of a DBA. You should deal with it, but honestly speaking, the chances of corruption are very less now.
No, the corruption, another disadvantage is, outages, right?
Outage?
Can lead to outages, right? I mean, the corruption can lead to outage, right?
Which we can deal by
Yeah,
high
yeah, yeah.
availabilities. Yeah.
These are, I'll put it in a different sense. These are blue moon scenarios. You will get it once in a while, not every time. Blue moon scenarios, very rarely you get to see them. So,
Vishnu, when we are talking about the corruption, it's like database block corruption or OS block
yeah,
corruption? I just want.
no, database block
Yes.
corruption. So we'll talk about those things later on, guys, not now. Let's wait. I mean, that is 28th slide. We still have 2
Yeah,
minutes. time.
Vishnu, you were answering earlier why there is like 127. It is not coming from the DB file multi-block read count. The number.
Yeah, that is related to batch to table access. We'll talk about that in the indexes part.
Okay.
Not now. That is nothing but batch to table access. We'll talk about that in the later part. So, guys, I am spending. See, I should have completed the 17 slides by now. So, we'll do one thing. If you have any doubts, please ping in the Slack. I have the Slack, Slack open here as well. So I'll try to answer that. You don't, so that we don't waste our, our time, and the others, who actually know these details actually may feel, a bit distracted as well. So let's keep on the doubts in the Slack. I'll try to answer each one of them, so that we get more time spending the, more time on the session rather than on the doubts. So let's talk about full table scans from the Oracle's perspective. So this is where I'm entering the full table scans now. So what all the factors that affects the decision? These are all the factors that affects the decision, guys. DB file multi-block read count, DB file EHCC read count, and optimizer read count. How these are actually related to this particular parameter, I'll explain everything in the next subsequent slides. Optimizer index cost LDJ, optimizer index caching, and system statistics also has an influence on the full table scans. We'll talk about all those things in the next subsequent slides. And the factors that affect the performance. So file system IO options, discussing IO, faster MTTR target, dirty blocks in the buffer cache, and also the blocks with active transactions in it. These also affects your performance of a full table scan. And you have to understand that a full table scan or a fast full index scan can be performed using either direct path read or DB file scattered read. So I'll try to explain DB file scattered read and direct path read in the next subsequent slides. You need to understand few fundamentals even before proceeding ahead with these things. So all these parameters will actually affect the session's decision whether to go with direct path read or DB file scattered read. We'll talk about each individual aspect of it more clearly, and there are even more fundamentals as well. So let's start with the very basics. Let me start with the very basics here. So you have executed a query. Oracle Optimizer has come up with a plan to perform full table scan. Now, how does the session proceed ahead? How does the session proceed ahead? How does the session even know which extents to read or which blocks to read? It gets the information by reading the segment header block. It gets this information by reading the segment header block. So let me just show you quickly how the segment header block actually looks like, and then we'll proceed ahead. So you get the segment header block information using DBA underscore segments view, guys. Here you have, sorry, not DB underscore segments. Yeah, DB underscore segments, you have the header file and the header block as well. So these columns actually give you the block which contains the segment header. So let me just dump a header block of students here. Header block of students. So let me dump it first. So the segment header block contains the details regarding all the extents that are allocated to this particular segment. Each and every individual extent allocated to the segment will be listed here. The segment header block contains the details regarding each and every extent that is allocated to the segment. It also contains the details regarding the high watermark information as well. It also contains the details regarding the high watermark information as well. So where does this segment header block reside? So this segment header block, you have to understand that when you create an extent, by default, depending upon deferred segment creation parameter. So let me just show you that as well. So deferred segment creation parameter, if it is set to true, by default, when you issue a statement such as create table, Oracle will not create a segment physically unless you insert the data into the So unless you insert the data into the segment. Now, as soon as you insert a row, the first thing Oracle does is Oracle allocates an extent to this particular segment depending upon the table space. I mean, if your table space has uniform extent allocation, then the initial extent size will be obtained from here, guys, from the table space itself. So if you have an auto allocation, then the default extent, the first extent allocated will be of the size 64 KB, in the sense 8 data blocks. So, Sai Kiran, can you please? So, you have to understand in a segment header, in a segment, I mean, in an extent, it's not the first block which is the segment header. So, depending upon the extent size, the location of the segment header actually varies. So, in a norm, if you are using an auto allocate, auto extent allocation table space, the extent location will be the third block. The third block will be the segment header. The segment header block will be present in the first extent that is allocated to the segment, and moreover, depending upon the size of the extent, if the initial extent is 8 KB in size, 64 KB in size, you will end up having the third block, which is the segment header block. The segment header block is also called as the L3BMB block space. So I'll talk about ASSM, Automatic Segment Space Management, in great detail in the when we are dealing with the wait events and everything. So you need to understand that once you use segment space management set to auto, Oracle will make use of bitmap blocks to track the freeness status. So these bitmap blocks are organized in form of a tree, guys. So L3 BMB blocks, L2 BMB blocks, L1 BMB blocks, etc. So the L3 BMB block is usually the segment header block. So we, for now, just for understanding purpose, think about the segment header block as an L3 BMB block. There could be other L3 BMB blocks as well, but they may not be segment header blocks. But remember that actually I'll talk about all those details in the later part. If I explain everything now, it will just overwhelm you with the details. I don't want to do that. So I'm just trying to introduce the concept here. The segment header block is also called as an L3 BMB block, level 3 bitmap block. So let me just show you the dump here. So the second level, in the L3 BMB block, you usually contains the detail regarding the extent map. I mean, extent map in the sense all the extent allocated to a segment as well. So you need to understand one thing here. In a segment header block, you contain the details regarding the high watermark information as well. So Oracle usually, while performing a full table scan, it starts with the initial extent allocated to the segment and then subsequently proceeds ahead. So it reads the extents in this particular order. By default, it reads the extents in the order in which they are allocated to the segment. So this is my initial extent that is allocated. So I end up reading this extent first, subsequently the second, third, and fourth, so on, till the high water mark is reached. So as the size of your extent grows beyond a certain point, an L3 BMB block or the segment header block can also point to other L3 BMB blocks. So I'll talk about these fundamentals in greater depth while we are dealing with the disadvantages or inherent side effects of automatic segment space management in the later part. For now, just remember that the segment header block is basically an L3 BMB block. So L3 BMB block contains the details regarding all the extents that are allocated to the segment. Yes. And it also contains the details regarding the high watermark information, as well. So high watermark in Oracle, you have to understand that there are two high watermarks, guys, not just one. There are two high watermarks. One is called as the low high water mark and a subsequent called as the high water mark. high watermark. So when you allocate an extent to the segment, by default, both the low high watermark and the high watermark point to the same block. But as you insert the data into the table, Oracle, what it does is it formats a certain ranges of blocks, not necessarily in this particular order. It can randomly select certain set of blocks in the extent. So, and then formats them. Once it formats, initially the low high watermark, I mean, Oracle, so I'll put it even in a different sense, so I don't want you to get confused. So suppose say this is an extent, guys. So Govind Dharmugam, please. So suppose say I have two high water marks in Oracle case. One is a low high water mark and another one is a high water mark. So all the blocks below the low high water mark position are all known to be formatted, and they can be either 100% used or they may contain the free space as well. The blocks above the low high water mark and below the high water mark, they can be either formatted or unformatted. They can be either formatted or unformatted. If they are formatted, they can be also either 100% used or they may contain the free space as well or 100% free as well. So you need to understand the blocks below, above the low high water mark and the high water mark, they can be either formatted or unformatted. So why does Oracle require the details regarding low high water mark and high water mark when I am performing a full table scan? Due to the fact that the blocks can be unformatted. So if the blocks are unformatted, Oracle knows by 100% probability that it's not 100%. I mean, basically, if the block is unformatted, there is no data in it. So there is no point in reading the unformatted data block. So Oracle, what it does is, till the low high water mark is reached, Oracle will try to make use of DB. Oracle will try to read as many blocks as possible till 128 or DB5 multi-block read count. And here it selectively reads only those blocks which are formatted. So let me just try to perform a SQL trace here and then give you the data. So you are in for a surprise again here. So let me just flush everything out. Show parameter file system IO options is set to set all. Yes. DB not active. This is my set SPID. Now I'm going to perform an SQL trace on this particular session. Select AVG of markdown from students. So how many entries do I see here, guys? Everyone? Hello? Can you notice?
Yeah, direct path read, DB file sequential.
I hardly see how many entries here. How many lines?
Maybe 20.
10.
Hardly 10, guys. Not less than 10. So, guys, can you please, as soon as you finish speaking, please place your call on mute, guys. So I hardly see 10 entries here. So now, the size of the table is close to 1 gigabyte. The size of my table is close to 1 gigabyte. And select count of star from DB underscore extents, where segment name is equal to students. I have close to 202 extents allocated to this segment. So why is my SQL trace not displaying all the results, guys? Everyone?
So it's just reading the formatted blocks, nothing else. Formatted extents.
So I'll put it even in a different sense. How many rows do I have here? 13.4 million rows. Obviously, I have all the data here. So I'll put it in even in a different sense. Create table temp2. Yes. Select star from student. So if I issue this particular statement, if I had many for unformatted blocks, I would basically have the details here. And moreover, the temp2 size should be considerably smaller. But no, I have the temp2 table size is close to 1 gigabyte, 1.1 gigabyte. Here, I hardly have 1, 2, 3, 4, 5, 6, 7 IO calls. Can you trust the SQL trace? So I'll give it in an even very good scenario. So now I'm going to flush everything out from the buffer cache on the shared pool as well. And I'm going to also even flush the buffers from the file system, I mean page cache or what you call, whatever you call it. So I'm going to run the same statement again. So now tell me guys, I read. So parallelly what I'm going to do is I'm going to issue an S-trace as well. So S-trace actually gives me the actual details. I ended up hardly noticing 7 IO calls or 8 IO calls here. But the S-trace gives me a different story altogether. I ended up making hell lot of IO calls. But SQL trace, I'm not even seeing 7 or 8 actual read requests. So is it surprising? Or the point is, don't assume that every single block read will be listed in your SQL trace. This is the biggest mistake the DBS usually make. So they assume that every block read or read operation will be written into your SQL trace. It's not necessarily true. It's not necessarily true. So if your IO subsystem is really fast, or in some scenarios, if the subsequent block reads are satisfied in a very short time, Oracle will not even have these details in your SQL traces. So here, this is a very good scenario. So I'm going to do another way. This is an NVMe storage. So I'm going to bring up my hard disk here. I do have my hard disk storage. So RAH SSR active. So the database is not yet up. So I'm going to bring up the database. Post starting the instance, I'm going to run the same statement here. The size of the table is almost close to 1.2 gigs. I'm going to run an SQL trace and then do the same as well. See, this is my SID or H SQL trace and select AVG of markdown from students. So here also, how many reads I am looking at this, everyone? Did I see even more reads than before?
1 or 2 more, I think.
Yes, slightly
Yeah.
increased.
So now, how many of you guys actually trust the SQL trace? So when you're dealing with a performance issue, if most of the details are not present, can you trust an SQL trace?
No.
No.
So you need to understand one thing, guys. Running SQL trace will help you only in certain circumstances only. So while troubleshooting a performance issue, the SQL trace is not required. So it is only for specific cases only it's required. It's not required always. And in fact, I'll tell you, I mean, even a surprise, in fact, for the past 7 years, I mean, I've stopped, come out of IT last year, last year, July. So considering even before that, my last 5 to 7 years, I never even required, I didn't even find a single valid use case while troubleshooting a performance issue to generate an 10046 trace. So you have to remember this going further. So this is the reason why, I mean, I started showing all these things. So don't assume that every read will be present in your 10046 traces. So now let me show you in a different aspect. I'll do one thing. I'll flush everything out from my caches, from the voice related caches. Once the caches are gone, I'm going to run the same thing again. I mean, don't assume that it is related to this thing, guys. Even in your enterprise level storage, you will never see these things. I mean, you will not see all the details present. So let me just quit everything. So now all the blog, I mean, my OS related page also I'm removing. I mean, this is a tier 2 hypervisor. Let me remove everything out as well. So now I'm going to run a trace again. Once this is done, I'm going to run the trace again. Let's see how many entries we'll have subsequently. You need to understand one thing when you are dealing with shared storage or environments wherein you have SAN or any other technology. I mean, most of your frequently accessed blocks are cached in the memory itself at the storage layer itself. So don't automatically assume that every block read will be listed here. So I'm going to run the same query here. Let's see how many entries we'll see end up seeing. This is the worst case scenario. This is what you call the worst case scenario, wherein not even a single block or a certain block, not even any block are basically cached either in the SAN layer or even at the file system cache layer as well. No blocks are cached anywhere. So this is the reason why I started seeing the entries. And in your environments, 99% of the time, you will have blocks cached, always cached, whether be it a SAN, be it NFS, whatever it is. You will always have the blocks cached. So you won't end up seeing the entire details. So this is the worst case scenario when it comes to reading the blocks from the disk, and the best case scenario for a DBA wherein he can see the entire details. So now let's go through the trace case. I'm basically looking at 128 blocks reads altogether. As I approach the end of the extent or the end of the segment, observe the block numbers here. As I approach the end of this segment here, I ended up reading only 48 blocks in one IO operation, even though the DB file multi-block read count value is set to 128. I ended up reading only 48 blocks or 32 blocks only. So this is because in a segment, especially above the low high water mark and below the high water mark position, the blocks can be either formatted or unformatted. Oracle will read multiple blocks to the full extent, or it uses the full 128 blocks. I mean, it ends up reading 128 blocks or it makes use of DB file multi-block read count value to the full extent till it reaches this particular point, is low high water mark. And post the low high water mark, Oracle ends up reading only those blocks, only those blocks that are formatted. So usually Oracle formats 16 blocks in a single, in a single go. So I'll talk about these things and all when we are talking about NQFB contention. For now, just remember that you will have the blocks in the ranges of 16 itself, 16 blocks which will be formatted and the other 16 may not be formatted. So only the blocks which are formatted, Oracle ends up reading here. In this scenario, I ended up reading 32 blocks. See here, this continuous chunk of 16 blocks are formatted, so I ended up reading 16 blocks. So here, these continuous chunk of blocks are 32 blocks, which are formatted. So Oracle read only these 32 blocks only. So here, 16 threes are 48. So I ended up reading 48 blocks. And you need to understand one thing. If you are to write data to a particular data block in a segment, that block has to be formatted. Only if it is formatted only, Oracle can insert the data into the particular block. So when you are inserting the data, if all the blocks are unformatted, Oracle does not simply format one block only. Oracle formats 16 blocks in a single operation. This can even go high. Oracle can even, depending upon the number of sessions inserting data and everything, there are other metrics that also come into the picture. Oracle can also format more than 16 blocks as well. So you need to understand. This is the reason why Oracle makes IO calls which are of very smaller size, especially once the low high water mark position is reached. So how does Oracle proceed ahead? So let me just bring up the slide here. So as soon as the optimizer comes up with a plan to perform a full table scan, it reads this segment header block first. So let me flush all the contents here and then show you the details again. H1 BD and flush. So I'm going to run the same statement again. Now let me show you the details here. So let me just scroll up. The first IO request that Oracle always makes is reading the segment header block using DB file sequential read. Oracle always reads the segment header block first, even before commencing the full table scan. It has to know which extents are allocated to the segment and which extents are not, or what is the position of the high water mark, or what is the position of the high water mark. All these details are present in the segment header block. So here Oracle always ends up reading the segment header block first. So you can validate this as well. So it says file number 7 and block number 346. So now this is select header file, header block from DB underscore segments. Where segment name is equal to students. Can you confirm it, guys? Everyone clear? This is the segment header block. You end up reading the segment header block first. In the segment header block, you have the details regarding the high watermark information and also the extents that are allocated to the segment. So you looking at the entries here, let me just turn the header block again. Header block of students. So you have all the scripts here, guys. You don't have to do JSON stuff. I have given you all the scripts here. These scripts are actually present in CD. So CD, once you log into Oracle user, you have this commands folder. In this commands folder, you have all these details here. So if you want to perform an SQL trace, all you have to do is run the SQL trace command and then pass in the SPID, not SID, instead SPID here. So I'll talk about more those things later on, but you need to understand one thing here. Oracle always reads from the initial extent that is allocated to the segment and it proceeds ahead You have to remember one thing. The main important point. So I'll just try to bring it here. So these are the blocks that are allocated to the segment. These are the blocks that are allocated to the segment. These are the blocks that are below the high water mark. And these are the blocks which are below the low high water mark. Especially here I have too many blocks between low high water mark and high water mark. So eventually I will have more reads with few blocks only. So that is the reason why you saw 16 blocks read in one IO operation, 32 blocks, and then 48 blocks. Even you saw more IOs related to reading. I mean, very few blocks only. So do you get it, guys? Any doubts here? You have to understand one important thing here. The information here, blocks below, especially with the low high water mark, this thing may not be accurate all the time, You will even end up seeing scenarios such as these. See here, if you notice, I'm going to just copy the same image here. So I'm going to copy the same image here. See here, I have close to 10,240 blocks allocated to a segment, and the high water mark position actually points to here. And moreover, even though there are even more blocks allocated, so sometimes you don't have this low high water mark information updated regularly. So this information may not be accurate. It is post gathering the statistics. This thing can be, this value will also be populated accurately. So don't assume that you will not always find the correct value here. So Oracle may or may not update the value. So in many cases. So I'm going to show you a very small example and then we'll proceed ahead. So I'm connecting to my SSD here. I'm going to run a load.
Vishnu, how Oracle chooses a low high watermark? It keeps on formatting in the background.
Low high watermark and high watermark, these fundamentals you need to read here. These are basics. So honestly speaking, you don't have to even read those. These are useless stuff. So the only thing you need to remember is in the context of the full table stack, once you reach the low high watermark, the blocks above the low high watermark, you don't get to see 128 blocks read in single IO operation. So you can end up seeing even reading 16 blocks in one IO operation. That is the main explanation. So you hope you get the point.
Yeah, I understood that point.
So now, what I'm going to do now is I'm going to close up. I don't want to get confused. So I'm going to start loading the data into my table here. So I'm going to load, suppose say 14 million or 10 million. So I've already loaded 7 million. Okay. 12 million rows. Now let me dump the segment header block. Header block was students. Let's see the data. So is the data accurate, guys, here? Hello? Everyone, can you see it? The data is not accurate. This thing will not be up to date always. So let me just restart the database as well and then show you the data. So let me restart it first. I think it is writing more dirty blocks. So yeah, I think it is restarting now. Let it restart. Post restart, I'm going to dump the segment header block as well. So when you are troubleshooting or when you are looking at stuff, don't be surprised that Oracle does not update all the details all the time. So usually people assume that Oracle is the best case. Don't think about it as this way. So even post restarting, is this block, the details are basically old, right? 20 only, right? Can you notice here? So
Yes.
now what I'm going to do is I'm going to gather stats on this particular table, and post which I'm going to dump the same data. Now it's been 2 hours and we are not even close to finishing it. Okay. So let me dump this, post gathering the statistics. It should actually dump. So now, can you see the database?
Yes.
So don't, don't basically think that, Oracle updates the data all the time. It does not update all the time. So there are too many things that you will notice in the next subsequent sessions as well. As the slides go on, you will end up seeing too many things. So let me just bring it here. So high water mark is very important. If you have too many blocks, ranges that are far apart from each other, then you will have too many IO requests, especially reading few blocks at the tailing section of your SQL trace, or I'll put it in a different sense. As you reach the end of your segment, if you have these blocks which are formatted, and moreover, if they are at random locations in an extent, then you will end up making several small IO requests as well. So this is one thing you need to remember. Oracle starts with the initial extent allocated to the segment first, and then it reads the extents in the precise order in which they are basically allocated. So now I'm going to ask everyone a simple question, guys. So will Oracle read one extent at a time while performing a full table scan? How many of you agree with this? Hello?
Yes. One extent at a time as sequential order.
So let me just show you a small example here. So this is my trace, which I have taken a while ago. So I'm going to take this particular thing here. Why did I write 16 plus space? So I'm going to show you the extent sizes as well. So let me, which host is it? Practice HTTP. Okay. H home EV. Select. Okay, one moment. I don't remember these things. So select file ID, block ID, blocks, fill DBA underscore extents, where segment name is equal to students order by 3 DESE. So I have the initial extent is of size 6K, 8 blocks, and the subsequent extents allocated are of the size 128 blocks. Now let's look at the trace here. So let me look at the trace here. So you are in for an even bigger surprise. So this block number actually says from which block I am reading these 13 blocks. I mean, this is the starting block number. So here, 347 actually should fall here. So 13 blocks I'm reading. Am I reading one extent at a time? Right?
No.
So is it really true that Oracle reads one extent at a time? Do you think that Oracle reads one extent at a time? Just by looking at the SQL trace and the extent IDs, can you determine that this is actual truth? So I'll show this in a different way here. Exit ORH home reading at active. So I'm going to perform a SQL trace here. And ORH trace -p. I'm going to perform both SQL trace and the trace as well. So AVG of markdown from students. Let me perform a filter extension. I'm going to cancel it for now. This is more than enough. And the hell, one moment, guys. This is more than enough. So I will submit calls. The initial set of block reads. How many blocks I'm reading? Am I not reading more than one extent at a time, guys? Everyone? Hello?
Yeah,
Yes.
kind of,
Yeah.
yes. But Vishnu, one thing to tell here.
Yeah.
One thing to tell here, actually, I mean, as per my experience, we have never gone into these details. So for some of your, questions, we don't have any answers, like whether we have given
No,
a
no.
thought.
No, I am just setting up your mindset for this.
Okay.
So I am just saying that whatever you learned till date may not be necessarily the truth. So I am just preparing your mind, and that's it. I am just preparing your mindset so that you get to understand that whatever you have learned till date may not be the necessarily the true. So until unless I show this, I mean, you cannot believe this, right?
Right.
So once you understand that,
right.
Whatever you have learned is not true, then you get to start, then you start seeing the real stuff.
Yeah, that's
That
right.
does it.
So,
Yeah, the only thing is, Vishnu, I mean, so even if you ask some questions, right, I mean, it takes some time for us to go through that. I mean, to actually let you know that how many blocks it is reading, right? I mean, since now we have not gone through it on a daily basis, actually. Yeah. That's why
so
it
you'll
takes
get to see these things, guys.
right.
So frankly speaking, you will get, if you are more into performance, more closely over and over again. So if you are purely into performance tuning,
We need to
Hi,
use
Vishnu.
this in practice, I think, later on.
yeah.
Yeah, Vishnu. I mean, does this depends on file system IO option we set?
Now the file system IO options is set to set all. That is the recommended value, right?
Okay, I mean, maybe in my environment, like maybe it may set to only none. So in that case, it will do only one segment at a time.
Vishnu, your voice is not audible.
Yeah, I have been on mute and then I have been speaking for quite some time. Okay. So it does not matter if your file system IO options is set to none or set all. You end up making large IO only. You end up making large IO only. So the true performance benefit you get to realize using the asynchronous IO is only during the index scans. I mean, that is when you get to see the major benefit. That is when you get to see the most benefit, not during a full table scan. So even during a full table scan, you get to see the benefit, but the extent is way more in during the index scans. So index probes, which are critical for any OLTP application, yes, you will get to see the benefit, and moreover, the benefit that you see, it depends on other factors as well. So we talk about those things in the later sessions. So now till now, once you understand, if you have understood that how does Oracle read, it starts reading the segment header block first. It gets the information regarding the high watermark information, be it low high watermark and high watermark information. Then it reads the extents based on the order in which they are allocated to the segment. So this is one thing you need to remember. So now let me proceed ahead with the next fundamental. So Oracle, while estimating the cost of full table scan, will not consider the blocks allocated to the segment phase. It always considers the blocks below the high watermark information only. While estimating the cost of performing a full table scan, Oracle always considers the blocks that are below the high watermark information only. It does not consider the total number of blocks allocated to the segment. Few may wonder why. Because what if I issue a statement, alter table allocate extent multiple times? I end up adding more extents to the segment which does not contain any data. In that case, there is no use in reading those blocks. So the high watermark actually remains the same, but the number of blocks allocated to the segment actually increases considerably in this scenario. So that is the main reason Oracle only considers the blocks below the high watermark to estimate the cost of performing a full table scan. So this value will always be up to date due to the fact that this value may not be accurate in all the cases. You have to understand why it may not use low high watermark. It is because this value may not be accurate all the time. So I just showed you. So let me just proceed ahead. So while performing a full table scan, what are all the possible cases? What are the different cases wherein Oracle will not read the blocks specified, the number of blocks specified by DB file multi-block read count? So I have already explained the initial extent becomes the starting point. You read the blocks belonging to one extent at a time. I said it can read. You just saw wherein two extents are read in a single IO operation. I mean, Oracle did read two extent blocks related to two extents in a single IO operation. This thing happens especially in cases where the subsequent extents are stored adjacent to one another. Do you get now, guys? Hello?
Yes.
It is only when you have your multi-block read count higher than the extent sizes and the subsequent extents allocated to the segment are stored adjacently. That is only when you end up seeing Oracle reading two extents in a single IO operation. But 99.999% of the time, you end up reading only one extent at a time. So that is one thing. Now, let's proceed ahead. While performing a full table scan, Oracle, be it asynchronous IO or synchronous IO, Oracle ends up issuing large IO requests, instead of reading 8192, I mean, instead of making each IO request, reading one block at a time, due to the fact that Oracle knows that all the subsequent blocks in an extent are stored adjacent to one another, it ends up making large IO requests. Synchronous IO, asynchronous IO performance actually depends on how the data is distributed among the available disks. So if you have striped data, so I don't want to dig into the in-depth details regarding the stripe sizes and everything, so I'll put it in a different sense. So if your data is not distributed properly, if your stripe sizes are not proper, then use of asynchronous IO may not give you more performance when it comes to performing a full table scan. The performance may be almost the same, may almost be the same. This happens especially in scenarios where your stripe sizes, I mean the storage administrators, if they have not configured the stripe sizes properly, this is more likely to happen. This is more likely to happen. Otherwise, if things are more proper, once you enable the file system IO options to set all, then once Oracle starts using asynchronous IO, you will see a considerable improvement in the performance. You will see a considerable improvement in the performance, provided that the data is striped across multiple disks. So I'll put it in a different sense. As soon as the Oracle issues an IO request to read 128 blocks in 128 blocks, it does not, if you are using asynchronous IO, Oracle will not wait till these 128 blocks are read. Instead, the process ends up issuing another IO request. So it can issue the multiple IO requests and then go ahead. After a certain point in time, it will end up seeing whether if the blocks are read or not using IO get events, wait events. So you have to remember, asynchronous IO improves the performance provided that if the data is distributed properly and if the stripe sizes of your volumes, RAID volumes are proper. It is only in those cases you will end up seeing good performance, I mean noticeable performance difference when it comes to asynchronous IO or synchronous IO. If not, you will not see any benefit. I mean, using both synchronous and asynchronous IO, I mean, you end up seeing the same performance. So this is also one particular point you need to remember. So if you enable the asynchronous IO at the database layer and you end up seeing no significant impact in the, I mean, significant difference, then it is a clear indication that, you know, what you call the stripe sizes may not be proper. So going ahead, we know that by now we already know that, one moment please. By now we already know that the blocks below, above the low high water mark and finally the blocks below the high water mark, Oracle ends up reading only blocks that are formatted. Yes, in this case, even though the DB file multi-block read count is set to 128, you end up making small IOs. There are other scenarios as well wherein Oracle ends up making small IOs while performing a full table scan. We know that Oracle reads one extent at a time. Suppose say here, my extent size is 48 blocks, but the multi-block read count is 32. In this case, Oracle ends up reading 32 blocks in one IO operation and then the rest 16 in another IO operation. This scenario is very less likely to happen due to the fact that you either have uniform extent allocation or auto allocate, and moreover, Oracle also rounds up the number of block read when performing a full table scan using direct path read. So I'll talk about these things in the later session. So you have to remember that it is in the cases wherein your extent size is misaligned with the DB file multi-block read code, you end up seeing additional reads, additional smaller reads, misaligned extent sizes with DB file multi-block read count, or indirectly put, extent sizes are good, but you have a very odd value for DB file multi-block read count. This thing happens during DB file scatter read. I'll explain that thing in more detail once we are, done with the fundamentals. So,
my question is related to table defragmentation. For example, as you said that Oracle first looks for the header segment, right, and then starts from the low high water mark.
If the table
until
is
the high water mark.
fragmented, I get what you're trying to ask.
Yeah.
If the blocks are not used, or if you have deleted hell lot of data, in that case, even in that case also, Oracle will read all the blocks. So I get it what you're trying to say. Suppose here my table is 1 GB in size, high watermark position somewhere here. If I delete the entire data here, what happens? In this case also, Oracle ends up reading all the blocks. So unless you shrink the table, the high watermark position will not move back. Do you get it? Deleting the data from the table will not shrink, will not move the high watermark position. It is only when you move the table or use the shrink space command, that is only when the high watermark position will be reset. Yes, the fragmentation does not affect the number of misaligned reads, but in fact you will be reading unnecessary data. This we will be talking about in the later session. What factors can cause more weights on during a full table scan? Not now, guys. We are just looking at the fundamentals only. Wait. So I have more than 50 slides here. I have to talk about the fundamentals. Then I have to talk about, ongoing transactions, what delayed, delayed commit cleanout can happen, ongoing transaction, chain rows, fragmentation. Can you see here? Musafir, right?
Yeah, that's right. So my point was like about the calls only, how many calls it will make.
Yeah. It will make the same number of calls even with the data and without the data. So if we still have too much content to cover, guys, don't.
Yeah, that's okay.
We too, how do I put it? Anxious, or we'll cover all those things. We still are looking at the fundamentals only. We need to go in a certain pace so that you remember things for a longer time. So, how does the optimizer estimate the cost for performing a full table scan? This is the exact formula that Oracle uses, guys. So you need to understand that it obtains the blocks below high watermark information from the statistics. If your statistics are not up to date, then the cost estimate, optimizer's cost will not be accurate, So if your statistics are not present altogether, in this case, how does Oracle determine the number of blocks below the high watermark information? This, it will get it by reading the segment header. Dynamic sampling kicks in if the statistics are not present. Oracle reads the segment header block to get the information regarding the how many blocks are present below the high water mark. So let's just see the chat section as well. So DB file multi-block read count, is there a way to identify what value you need to set it to? We still haven't crossed that particular point. Ram, I think we will discuss about it in the next subsequent slides. So Please be patient. Now, let me run a simple query and then show you the cost base, whether if it actually is accurate or not. So this may not be necessary, but this is very important when you have to look at certain aspects. So that is the reason why I'm basically showing you that as well. So now I'm going to close all these sessions out. Due to the, I want only things to be running from my SSD. So set size. So I'm going to gather the stats as well, guys. So drop table empty. Not gather stats. Students. So once the statistics are gathered, I'm going to run an optimizer trace on this particular session. I'm going to flush everything out, shared pool and the buffer cache as well. So just in case. So now this is my session. So the active script, guys, this is very helpful when you are dealing with performance issues. It will list you all the sessions that are active. So now I'll show this and then we'll take a break, guys. So 5 minutes or something like that. So OPT trace, optimizer trace. So select AVG of Mark 1 from students. Let's look at the cost case. Let's look at the cost here. So the cost, let me just bring it here. It says 33,781. Let's see whether this thing is accurate or not. Blocks below the high watermark information. So I'm going to dump the header block as well. Go to home, header block of students, more. So I have the details here. Let me just bring this data also. Let me just paste the header information here, segment header information. And you need to understand one thing from the formula. Oracle considers these statistics as well. MBRC, M read time, S read time. If your system statistics are not present, then Oracle calculates these values, guys, using these formulas if your system statistics are not present. So if your system statistics MBRC value is not present, by default, Oracle uses optimizer read count value to estimate the cost. It's not a DB file multi-block read count. It's never the DB file multi-block read count. DB file multi-block read count is never used to estimate the cost while performing the full table scan. It's always either DB file optimizer read count or MBRC for a value from your system statistics. Only one of these values are used. If you have system statistics, then Oracle will use MBRC value. If you do not have system statistics, Oracle will use DB file optimizer read count value. So by default, if you allow Oracle to calculate or determine the value of multi-block DB file multi-block read count, by default, Oracle will always set optimizer read count value to 8 days. If you do not manually set DB file multi-block read count value, or starting with 11J, Oracle recommends you not to explicitly set a value for DB file multi-block read count. So if you are not setting a value for DB file multi-block read count manually, and if Oracle is automatically gathering, if Oracle is automatically calculating the value of multi-block read count, then Oracle uses DB file optimizer read count value. So provided only if system statistics are not present. So let me just show you here. Select linear eval1 from stats$. So I don't have MBRC value calculated here. In this case, I mean, in my database, I don't have system statistics. So in this case, Oracle by default will use this particular value. So here, let me just take a screenshot of this. Let me show you how things are calculated as well. So M read time, I don't have the M read time, S read time in my system statistics. These are zero values. In this case, Oracle will gather like this case. IO seek time is 10 here. 10 plus optimizer read count value by default is 8. 8 star DB block size is 8192 and IOFRS speed is 4096. To M read time, Oracle calculates it as 26 value here, and S read time by default will come to, this is 10, 10 plus 2, 12 guys. So now we know the value of M read time and S read time from this formula. Blocks below the high water mark, we already know that. 1, 2, 4, 3, 3, 7 by 8 will give me this value, and star 26 by 12. Is this approximately correct, guys? Everyone? Here.
Yes. Yes. Yes.
Approximately.
Yes.
So that is why I included approximately symbol here. So it is approximately equal to that. So don't assume that Oracle will consider the blocks allocated to the segment. So what if I allocated more extents to the segment? In this case, the number of blocks allocated to the segment will be way more higher. So Oracle will never use this particular value. Oracle always uses the blocks below the high watermark information only while estimating the cost. So now I have the statistics gathered. Now what I'm going to do is I'm going to delete the stats altogether. So in this case, Oracle does not have a clue as to, due to the fact that the statistics are deleted, Oracle does not have a clue regarding how many blocks are below the high watermark information. In this case, how does Oracle find out the value? So here, what Oracle does is it reads the segment header block. It reads the segment header block. So I'm going to run this statement again. Let me show you in terms of cost first. So this is somewhere here. Can you notice the cost case? Did Oracle accurately estimate the cost? Even when the statistics are not there? Guys? It is during this particular dynamic sampling query, the segment header block will be read. So here, dynamic sampling query, did it provide the details? Everyone? Can you see here?
Yes.
Yes.
Dynamic sampling query, yes. This gave me the details, so you need to understand.
So, Vishnu, if the stats are present, then the dynamic sampling will not be executed. Is that what you are trying to say?
What I'm trying to say is, in the absence of statistics, Oracle will get this information. So if the statistics are not up to date, what if the dynamic sampling did not kick in? In that case, optimizer cost estimate will be wrong.
Okay.
So don't assume that dynamic sampling will always kick in. So there are too many surprises over the course of next 48 days. You will see. Go wait, be patient. So
So dynamic sampling will happen during stale state also?
yeah, it's purely up to the optimizer. So even if the statistics are 100% accurate, Oracle can still trigger dynamic sampling queries. So we are not yet there. We are still looking at the basics. So we are going to take 5 minutes break. It's been almost 2.5 hours. So any doubts during this time? Hello?
Hi, Vishnu. It means the stats should be up to date or there's no stats at all.
Amit, your voice is breaking. Can you ping the question?
Okay. No
He's
problem.
asking whether stats can be up to date or not.
Hey, your voice is also breaking, man. Can you ping the question? I mean, for the past 2 months, I have noticed that the people, especially attending from and North India, like Mumbai or Delhi, or people who are attending from the East Coast, their voice usually gets broken. I don't know why.
So Vishnu, for stats, we'll have another deep dive, right, in coming days.
Yeah, we'll have it.
Okay.
Yeah, the statistics should be either. It's always better to have up-to-date statistics phase.
Okay.
So
Yeah,
you
because
as a DBA should make sure that the default statistics gathering job that runs every night actually gathers the statistics. If it does not, you will have a hell lot of issues. So we'll actually look into those more in depth in the subsequent sessions. So
thanks.
So first thing, don't assume whatever you have learned till date is exactly the same base. I mean, so there are too many places wherein whatever you have learned till date, I mean, may not be necessarily the true. So you will end up being more surprised over and over again. And don't be curious. I mean, be curious, but don't go too far into the concept space. I mean, I'll cover almost most of the things. So slowly we'll cover everything. And moreover, if you have any doubts, please don't interrupt in the middle. I mean, honestly speaking, 45 days into 45 days into 2 hours will give you only 90 hours. 90 hours may not be sufficient. Ashish, can you place your call on mute? I can see echo. So the for 90 hours may not be sufficient. So that is the reason why, if you are interrupting in the middle, yeah, I don't have a problem answering. But we'll lose the pace.
Got you,
Vishnu,
Vishnu.
one question from my side.
Yeah, Ashish.
Yeah, Vishnu, recording will be available after the session or it will be available at some time later?
Hey, I will not give the recording to you, man.
Why I am asking is because you are going at such a pace, I have to watch recording twice to understand.
No, I
the
told
master
you before commencing the course, I will give the videos. I mean, it takes 2 hours or 3 hours for this GoToMeeting to transcode the video. As soon as that is done, I will share the video. And please, I am requesting everyone, please don't share these videos.
Sure, Vishnu. I will never share. I hope nobody will share.
So I'll send it as soon as this, it takes at least 2 or 3 hours. So I'll put it in a different sense. Weekend sessions, we have a marathon 4-hour session. So as soon as this recording is available, I'll share it across. So, and moreover, I have observed that, the recording, they have some expiry time or something. I mean, GoToMeeting has recently come up with that. So download it as soon as I share it. Otherwise, you will end up missing the link gets expired. I have to again go there and then again share it. So try to download it. And moreover, weekday sessions, due to the fact that I conduct in the morning and the evening. So I will select one of those sessions which has more data. Or if I have explained a few things, even additional details in the evening session, then the evening session video I will share, not the morning sessions. So the best among the 2 sessions will share.
Vishnu, I mean, on the weekend classes, right? Will it be on every Saturday, the 4 hours? Or? Okay.
Yeah, you have paid 15,000. I have to do justice for your 15,000. It's up to you whether you have to ignore it or not.
Right.
Yeah.
But I mean, it will be
So
4 hours on every Saturday or 2 hours going forward.
yeah, 4 hours punishment for the next 6 weeks, man.
Okay, and Saturday
So
and I mean Saturday, Sunday, or
Sunday,
only
no
Saturday?
Sunday
Okay.
evening, Sunday holiday. Even I need to.
Yeah, got it.
And then we need
Yeah,
to
because
watch that movie twice to understand what we learned on Saturday.
I didn't understand.
I am saying, Vishnu, Sunday we need to watch that recording twice to understand what we learned on Saturday.
So I'll put it in a different sense. Ignore your life for the next 6 weeks. So every Sunday, try to revisit every video that has gone through the. I mean, Monday, Tuesday, Wednesday, Thursday, Friday, 2 hours each. So 10 hours, and then weekend 4 hours. So 14 hours. Try to watch it on Sunday itself. So
Actually true. Yes.
I mean, don't watch the entire video, man. I mean, you don't have to listen to this rambling 5 minutes or 10 minutes, right? Me ramble about, some stuff. So you can just skip over and then, remember the important points. So that's it. That's more than enough. And moreover, everyone, I am not a trainer, guys. I am not a trainer. So I'm not making a living out of this course. I just want to share the knowledge, whatever I have gained over several years, and then I'm trying to share it as much as I can in a very short time. So I am completely into a new I am completely into manufacturing these days. So that is one thing, guys.
How you came
Yeah.
into Oracle then?
Huh?
You came to Oracle side, my database side.
So the first job I took was an Oracle DBA. So it continued that way. Then I actually came out of IT. So if anyone are even trying to write OCM, I can help you. Help you in the sense I can guide you. I've already written 2 OCMs, 11G and 12C also.
that guidance is very important.
Yeah, I can guide you. I mean, honestly speaking, that is one bullshit exam. Honestly speaking, so that is one easy exam. So I can help you. In fact, I did help many people in the past as well. So if you really want to become an OCM and if you are really into that, one word of advice, it's pointless becoming an OCM considering how the market is moving ahead. And 2, if you are still okay with that, then that too, if you have a strong desire, then only come, then only pick. Otherwise, don't pick. If you are slowly looking.
Vishnu,
So,
I have one thing here. So Oracle is bundled with so many features. So nowadays in the market is coming up with a lot many open source. Now Amazon has already challenged Oracle that we will be moving like they have already moved everything into their Aurora. So like
in fact, I did move a few databases
yes,
there when
yes,
I was
yes,
working in
yes, yes.
Amazon.
Yes. So like I just wanted to understand Oracle invested hell lot of time in writing all the features which are not relevant or not
Okay.
useful
Yeah.
at all. So that is
No.
what
I'll put it in a different sense. My comment is so Sony, LG, they have invested billions of rupees, billions of dollars, while developing CD drive, right?
Yeah.
Now people are using pen drives, right?
Yes.
So the technology, what I mean to say is, I mean that there is a shift in the mindset of the people. So why should I pay $50,000 for a license?
But application scalability, the transaction scalability should also meet with the existing.
No, man. See, I'll put it in a different sense. So select name value from $3 where name is equal to execute count. So this statistic, execute this query every 1 second in one of your most critical environments. So this is a basic query which gives you a statistic value. So execute it at every 1 second interval. So it will list you this increment, I mean the value whatever is increased, it will tell you how many executions per second happened. So you will not even see 5,000 or even 10,000 guys. You will not even see 10,000 SQL statements executed in a particular database. So I'll put it in a different sense. Postgres or even MySQL, these days, due to the fact that the hardware has improved, even the core counts has increased significantly over the past 4 years. So a single server, single rack server can hold close to 128 CPU cores. Now, in the current market, you can have 128 CPU cores, and I put it in a different way. 256 hyper-threaded or vCPUs you can have in a single rack itself. The cost of this box is less than $10,000. So $10,000. So as a business owner, do I have to pay 128 into $50,000 for getting an Oracle license, or to use Oracle database on this host, or can I get 5 of these machines and then run it using Postgres? Do you get it? The market
Yes.
shift is happened. Yeah, that's the main reason.
Yes,
Nothing
I
else.
understand. But still, in the banking and the this
No,
telecom,
banking also they're
especially.
moving out. Ramu, banking also they're moving out. So I can't tell you the actual things. I mean, many companies have even started moving. So now let's go back, guys. We have already wasted 15 minutes here. So system statistics also has an influence on the cost estimates, guys. You have seen the formula. So if you have system statistics, Oracle by default uses the MBRC value from system statistics to estimate the cost. So let me just show you that. I mean, I'll gather the stats here. I'll gather stats, students. So once the statistics are gathered, I'm going to flush everything out, and I'm going to run an optimizer trace to show you the cost. Post which, what I'm going to do is I'm going to change the SRead time and the MRead time values at the system statistics level, and then basically show you the data again. So MRead time, I'm going to set it to SRead time to 12, sorry, not 12, 20. And so I'm just trying to set this manually. That's it. I'm not doing any James Bond stuff here. So before that, I'm going to run an optimizer trace here. OPT trace. So I'm going to run the query which performs the full table scan here. I have the Markdown text students. Now I'm going to gather the cost here, just the cost part. I'm going to take a snapshot of the cost section here itself. So let me take this now. Let me copy this and then paste it here. Now what I'm going to do is I'm going to manipulate the system statistics here. I have set the system statistics here, and I've also flushed the buffer cache with the shadeful. I'm going to execute the same query again. Now let's consider the cost base. So I'm going to scroll down now. I'm going to scroll down. So it should be somewhere here. So did you notice the cost base, everyone? Difference in the cost? So your system statistics play a major important role when it comes to estimating the cost while performing a full table scan. DB file multi-block read count will not be used if you are not setting the DB file multi-block read count, and if Oracle is automatically estimating the value to be, suppose, say 128. This 128 value will never be used, guys. Oracle will always use DB file optimizer read count value while estimating the cost. That too only if your system statistics are not present. If your system statistics are not present, that is only when optimizer read count value will be used to estimate the cost. If your system statistics are present, Oracle will simply ignore the DB file optimizer read count value. So System statistics do not gather at wrong intervals, guys. Gathering the system statistics at very wrong intervals can lead to insanely bad values. So I'll just run this here, select pname, pval1 from system of stats dollar. So I'm going to take a snapshot of this now. I mean, I've set this manually now. Anyhow, so I'm going to just take a snapshot here. So what I'm going to do is I'm going to run a small workload here on this database, small workload on this on a different database. So I'm going to show you this is a different code. I'll try to share this code as well, guys. I actually forgot to. I think I have shared this. Do you have this particular class file, guys, in the jit.7z? Everyone?
I guess yes, but
So this
maybe not reflective.
So I'll try to explain this when we have the time, guys. Not now. So tomorrow, I mean, once we reach, once you guys reach a particular level, then I'll start explaining what this Java stuff. So how to make use of these classes and everything. So you need to learn Java as well, guys. So this will actually help you a lot. So now the first thing is I have to create a table and then basically run the load. So now let me just create the load. Create the thing and then run the loop. So one moment. I have to change the IP address as well. 10.1.20 So I'm running the load now. First, what it does is it basically loads the data into the table. So let me close all these sessions as well. It loads the data into the table, the system stats table. Once the data is loaded, it basically runs a particular random workload. It basically runs a random workload. So here I have 1, 2, 3, 4, 5 threads running full table scans and 5 threads basically running index range scans. Yes, in Exadata environments, you need to mandatorily gather the system statistics. That too, you have a specific option there. While gathering the system statistics, I think there is a particular option. We'll talk about that when we are dealing with related to Exadata. Yes, you need to gather Exadata. I mean, when you are gathering statistics, system statistics, you need, I mean, Exadata environments may mandatorily require system statistics. So now let me see the activity on this particular database. Yes, I am looking at activity here. So I am gathering the statistics at a particular point in time wherein I have 5 sessions performing full table scans and then 5 sessions performing index range scans. So now I'm going to stop the basic and finally dbms underscore stats of gather system stats. I'm going to stop this as well. Finally, let's see the system statistics. Flush everything, select name. So this is one statistics here. This is one workload statistics. I'm going to run a different workload here. So instead I already have the table, so I'm going to just run the workload here. So these are the current values. I'm running the workload here. Here, in this case, I have close to 8 sessions performing full table scans and only 2 sessions performing index range scans. So my workload is more towards full table scans. So now let's wait for suppose say 10-15 seconds. Then, okay, I think this is more than enough. So I'm going to stop this now. I'm going to gather this, stop the statistics gathering job, flush everything out. Now select the values again. So let me take a screenshot of this. So CPU speed can see a significant difference in these values, guys. Everyone, even the MBRC, you will notice it. I mean, for now, due to the fact we have time constraint, I'm just trying to stop I'm going to just show you, I'm just trying to show you that gathering the system statistics at wrong periods can result in very skewed values. This can actually influence the optimizer cost estimates considerably. So do not gather system statistics unless you have a representative workload. Unless you have a representative workload, do not gather the system statistics. Only gather these statistics if you have representative workload, or if your workload is basically very good, or I'll put it in a different sense. So if my workload starts at 9 a.m. and at 6 p.m. it finishes, the workload is basically uniform throughout the day. Then start gathering system statistics here and then stops gathering statistics here. So if I am gathering system statistics, suppose say post 6 p.m., when there is very less activity, this does not truly represent. I mean, you will end up with very skewed results. The results may not be very good. So do not gather system statistics at the wrong time. You gather only when your workload is representative. In shared environments, if your storage is shared, or even if your physical box is shared, don't gather system statistics, guys. If your environment is a shared environment, in this case, I mean, don't just think that you have multiple databases in a single box, single VM. If it is a virtual machine, the blind rule is don't gather the system statistics, because you are sharing the physical host with multiple VMs, and also it is more likely that the IO is also shared by multiple VMs. And due to the fact that you are clueless as to what sort of workload the other machines can start at certain times, I mean, this can actually result in
Vishnu, your
very
voice is
skewed
breaking.
values. So can you hear me now?
No, there is a lot of cranky voice actually.
So can you hear me now properly?
Yep, now it's better. Yeah, now it's
Yes,
better.
better.
So do not gather the system statistics when the environment is shared with, or I'll put it in a different sense. If you have a virtual machine
Again.
which hosts, so can you hear me, guys? Not clearly now? Is it still not clear?
Yeah, the
Now
moment
it
you
is
were
clear.
asking,
Yes,
it
clear.
Now
went
clear.
back again, it's going back.
Yeah, your
So
voice tend
let,
to tear out at the end.
so let me just try to rejoin. So I'm back again. So remember, guys, if you have a shared environment, in the sense, if you have a virtual machine with multiple databases in it, or if you have a host machine wherein you have multiple databases in it, so I'll put it in more very good context. In a particular machine, if you have different databases, or if this machine is running several VMs, do not gather system statistics. System statistics do not gather. So that is the thing, guys. So system statistics a big no. And moreover, you have to remember one thing. There are many blogs, many websites. They say that M-read time should equal multi-block read count into S-read time. This is really bad. This is really bad. This assumption is completely wrong. This should, I'll put it in a different sense. Even Oracle Metalink, there are few documents that suggest M-read time should be equal to somewhere close to, should be equal to approximately close to 128 star S-read time. This is not necessary. This is a wrong thing altogether. Suppose I'll put it in a different sense. This is my disk. I'm reading a block here. So S-read time, suppose say it's 1 millisecond. If all my blocks are stored adjacent to one another, basically this is what happens when you are reading multiple blocks in a single IO operation. So do you think if reading 128 blocks, do I end up causing 128 milliseconds? Everyone? Will it cause 128 milliseconds?
No.
No.
So this assumption is completely wrong, guys. So there are few documents even, they suggest that, your M-read time should be equal to, 128 times S-read time. That is completely wrong. That is a very bad thing altogether. So you need to remember that. Finally, now we are coming on to the actual stuff here. This is where things get really interesting. So all the things that we have discussed till date are not even the basics. So these are the basics, or these are the real stuff, guys. So Oracle, starting with 11G, Oracle says, do not set the value of DB file multi-block read count parameter. Oracle says, do not set the value of multi-block read count value. Instead, let Oracle calculate this value automatically. How does Oracle calculate this value? It uses various statistics such as various things such as database block size of your buffer cache, number of sessions, your sessions parameter as well, and also certain OS related stuff such as optimal IO size as well. Oracle considers all these things during the instance startup and then sets the value of DB file multi-block read count accordingly. So I'll do one thing. Here, I'm going to reduce the size of my buffer cache or the SGA, reduce it considerably. Let's see the value case. So now I have the database show parameter SGA. My SGA size is 892 MB. So now I'm going to reduce, and moreover, let me show you the value. Show parameter DB file multi-block. It's set to 128. All the system set SGA target is equal to 500. Scope is equal to SP5. Scope is equal to SP5. I'm going to restart the database now. So due to the fact that I've reduced my SGA target, eventually my buffer cache will also get reduced. So post restart, let's see the value of DB file multi-block read count again. So let it restart. I should have started it force using the force option. Can you see the value, guys? Everyone? It's 81. Don't assume that Oracle always comes up with 128. It is basically dependent on various factors such as database block size, buffer cache, or even the number of sessions as well. So what I'm going to do is I'm going to increase the buffer cache considerably here. Indirectly by increasing the SGA target. Scope is equal to SP5. Out of system set SGA max size is equal to 4 gig. Scope is equal to SP5. Out of system set. So show parameter process, show parameter sessions. So out of system set processes parameter is equal to, suppose say 14,000. Scope is equal to SP5. So I'm going to restart the database. So instead start of course, show parameter db file multi-block. Let's see the value again, guys. So this is to demonstrate that indirectly Oracle also considers the sessions parameter value, the value of sessions parameter as well. During the instance startup, Oracle considers not only the database buffer cache, but also the number of sessions as well. So if you are increasing the sessions parameter or indirectly increasing the process parameter as well, if you are increasing bit by 100 or 200 value, you may not notice the change in the DB file multi-block read count. Oracle, in some cases, you would end up seeing it is only when you increase the sessions or process parameter significantly, that is only when, suppose 1,000 or 2,000, that is when you get to see a difference in the DB file multi-block read count value. So these are the changes that DBA actually makes. So I'm going to show you a very different scenario. So I don't think, let me see if I can replicate it. So if I can replicate it, that's well and good. So I'm going to bash. So I'm going to do one thing. Create e file from SP file. I'm going to delete all the settings that I've done, guys. So I don't want this process parameter coming up. I've set it to a very high value. So I'm going to set it to 320 back. And SGS size to suppose say 850 or 860 MB. So it's very hard in certain scenarios to especially come up with this. So let me just try to see if I can replicate this. Otherwise, you can simulate it as well in your environment, because this is an NVMe storage here. That's the main reason. So let me just flush everything out. From the buffer caches and everything in my page cache and everything as well. So once that is done, I'm going to flush my file system buffers as well. So let it complete. Once it is complete, what I'm going to do is I'm going to start up the database. If we are fortunate enough, we may see non-standard value for DB file multi-block read count. If you are fortunate enough. So this happens especially in certain environments where you have if your storage is not substandard, if your storage underlying storage is substandard, in this case you would end up seeing very low values for multi-block read count as well. So I think I should be very fortunate enough to get the value here. Otherwise I will end up seeing 128. Yeah. So I'll put it in a different sense. If you use substandard storage, Oracle can also come up with 81 or 90 or something like that as well for multi-block read count value. So as soon as the data get cached at this SAM layer, the subsequent database restart, this value gets reverted back to 128. This thing also happens. Don't just assume that Oracle always comes up with 128 value after every restart. In certain scenarios wherein you have this substandard storage configuration, in these cases, the post restart, the value can either increment or decrement as well. So the automatic calculation will not always result in 128. This is one thing. It is actually dependent on all these factors as well. And apart from these, your storage config, how the things are configured at the storage layer also does have an impact. So this is very hard to simulate, guys. In only explicit conditions, I'll end up getting it. So I'll do one thing. I'll try to change I'll try to use a different Mac tomorrow. So different system tomorrow. So I'll have it there. So tomorrow I'll see if I can replicate it. I mean, in another system I can replicate that. In this system, I don't think because I have an NVMe storage here. So I'll try to showcase that in tomorrow. So you need to remember that even the storage also things can get really. I mean, the database value, DB file multi-block read count value can also change post restart also. Don't assume that Oracle always comes up with 128 value. Apart, even though you don't make the changes to DB file, I mean the buffer cache or even the number of sessions as well, even in those cases, even then Oracle can come up with a very weird values as well. So non-standard environments in the presence of caching at the storage layer can trigger a change into DB file multi-block read count value as well. So if you are provisioning databases, so always be sure that your your storage is a standard storage. Don't go with some third parties. I'll put it in different sense. Don't end up saving money on your storage. So go with a very good storage vendor. So otherwise you'll end up seeing, hiccups such as this as well. So coming back to the DB file multi-block read count. So how many of you guys actually think the value of this parameter is used while performing a full table scan? Guys? Everyone?
Yeah.
Yes.
So show parameter DB file multi-block read count, it is set to 128. Does Oracle read 128 blocks in a single IO operation? No, it is not true. In fact, Oracle uses SS hidden DB file exec read count. This parameter is actually used. The value of this parameter is actually used while performing a full table scan. It's not DB file multi-block read count. So I'm going to set it at the session level here, guys. Alter session set. Suppose say 3 blocks here. So I don't want an odd value because there is another fundamental that also comes up when you use odd value. So I'm going to set an even value here. So let me show you the values. Show parameter DB file multi-block read count is equal to 128. So show parameter DB file exec. Let me run a full table scan here. Let's see how many blocks it reads in a single IO operation. Select. How many blocks is it reading, guys?
It's not reading. It's only waiting.
2 blocks.
Two blocks.
So my multi-block read count value is set to 128. So you have to remember that this is a dummy parameter. There is a relationship between DB file multi-block read count, DB file optimizer read count, and DB file exec read count as well. But if you have to understand the true functionality, Oracle, while sessions are performing a full table scan or fast full index scan, Oracle say these sessions always use the value of this parameter only. It's not the multi-block read count. So DB file optimizer read count is used only when the system statistics are not present. So there is an interesting relationship between these 3 parameters. So I'll try to explain that. So now I'm going to delete the system statistics here. So delete system stats. So select, I want to make sure that they are gone. So yeah, the values are not there. Now, what I'm going to do is, so even interestingly, there is one important thing that you have to remember, guys. So I'll do one thing. So let me just show you. Let me restart the database as well. So now you have to understand that if you are allowing Oracle to determine the value of DB file multi-block read count, or you are going with Oracle recommendation and then you are not setting any value for this particular parameter. In this case, Oracle automatically determines the value of this parameter. Yes, we know that. We have already seen what all factors can actually come into the play while calculating the value of this parameter. Yes. So if Oracle is automatically coming up a value for this particular parameter, regardless of whether if it is an odd value or an even value, Oracle automatically assigns this value to DB file exec read count as well. So if you have to understand that when it comes to DB file exec read count, this value will always be equal to DB file multi-block read count, regardless of whether this parameter is calculated automatically or whether if it is manually set. So here I have this value calculated automatically. Show parameter DB file multi-block read count. Here DB file exec read count. If I set the value of this particular parameter manually, then Oracle automatically sets the same value to this particular parameter. So you have to remember these values, the parameter, DB file exec read count and DB file multi-block read count, the value of both these parameters will always be equal, regardless of whether DB file multi-block read count, this particular parameter is either manually set or automatically calculated. So usually, we don't know the relationship between these two here. So that's the reason why people always assume that it's this value which is basically used. It's not necessarily this case. Sessions always end up using DB file exec read count only. So there is one.
Can we hard code these two values differently? So the system would not change, modifying the DB file multi-block read count to execute read count. So if we set it forcefully.
Why do you want to change it? Yeah, if you change that, only things will happen. Weirdly.
That's what. So during the time of tuning, so if you find this execute read count,
no, you never find it. You will never find it, Ram. I just wanted to show you. So if you are thinking, this class is to help you guys understand that whatever the things you have learned till date are not accurate. So I'm just trying to build up that. So you get the point, right?
Got you. Yeah.
So slowly you will get to see, as we go through the advanced topics, you will get to see, more of the interesting things as well. So suddenly, if I say, things do not work as expected, people will say, hey, this guy is saying something. So you just have to see things in a different view. So one moment, and in any environment, you will not have these values set to these parameter values set differently, unless you have a DBA who got really frustrated by your manager and then he is leaving the company. So unless that situation, you will not have this. So you will always have the equal value space. And moreover, you need to understand one thing. So let me just bring up the formula of DB, the full table scan. You have to understand one important point here. If you are allowing Oracle to calculate the value of DB file multi-block read count, even though it comes with 128 or 81 or 64 or 32, whatever it is, if Oracle is automatically calculating a value of, if Oracle is automatically calculating the value for DB file multi-block read count, then if your systems, then Oracle will by default set optimizer read count value to 8 days. So you have to understand this is the parameter used in estimating the cost of full table scan. If you are allowing Oracle to determine the value of multi-block read count, then this value will always be set to 8. So this has very strange implications. Most DBS actually don't know this. So I'm going to do one thing. Alter system reset DB file multi-block read count. If I reset this particular parameter, let's see whether if it is set to 128 again. It will not. So for that, I need to restart the database out of force. Once I start up the database, I'll show you an interesting phenomenon here. So home VB, exit home VB, and active. So I'm going to perform an optimizer trace phase, show parameter, DB file, multi-block read count. Yeah, it is automatically calculated, and moreover, Oracle automatically determined the value to 128. OPT trace. So I'm performing a full table scan here from students. Let's see the cost. Let's see the cost of performing a full table scan here. The cost is somewhere close to 33K. So in certain situations, so due to the fact that most DBS do not know the relationship between DB file multi-block read count and DB file optimizer read count, they believe that Oracle automatically calculating this value to 128 is equal to manually setting this value to 128, guys. So now I am setting this value to 128. Now let's see the cost again. Let's see the cost again. So Oracle did come up with a full table scan here. Let's see the cost again. What happened, guys, here? Did the cost reduce? When Oracle automatically determined the value for DB file multi-block read count to 128, the value is cost is 33K. When I manually set this parameter value to 128, the cost became very less. Why? Because DB file multi-block read count and optimizer read count are both related. So if I manually set the value of this particular parameter, then Oracle automatically sets the same value for here. You get it, guys? If I am setting a value to suppose say 64, then Oracle, so let me just set it to 64. Let's see the value again.
Vishnu, after you reset the value, can you flush the buffer cache and then run so that?
So I'm resetting the value, flushing the buffer cache. So it does not work out here. I have to restart the database. So now I have reset this particular parameter. So in this case, Oracle will automatically determine the value of this particular parameter. Now it will come up, eventually we know that it will come up with 128. So here Oracle is automatically calculating the value. So in this case, optimizer read count will always be equal to 8 value. Will always be equal to 8 value. Can you notice, guys? This is a very interesting thing to remember. Do not set the value of multi-block read count manually. This will screw up your cost considerably. This will screw up with your cost considerably. So let me just show you the slide here. I just showed you. So you need to understand one important thing here. So let me just execute a different query. Home VB and active. So I'm going to run an optimizer trace here. So the optimizer trace is on. Select AVG of mark one from students. Then subsequently alter system set db file multi-block read count to 8 value. And I'm going to run the same statement again. Let's see the cost in both the cases, guys. So when I manually set the value to 8, I'm going to take the cost. So let me just scroll up. So this is the cost here. I'm just copy it here. So when I manually set, this is when I manually set the db file multi-block read count to value 8 here. So I'll just show you the parameter as well, just in case if you want to notice it here. So somewhere db file multi-block, can you notice here, guys? Hello? So now I'm going to scroll up here when Oracle automatically calculated the value of multi-block read count. So I'll just compare the cost here. Here in this case, the value of multi-block read count was 128. So you have to understand that due to the fact that Oracle automatically sets the value of optimizer read count to value 8, when this parameter is calculated automatically. So if you are letting Oracle to determine the value of this particular parameter, by default, optimizer read count will be set to 8. If you are manually setting this parameter to 8, in this case, may 8 or 16 or whatever it is, due to the fact that Oracle assigns the same value. Here, setting the multi-block read count value to 8 and letting the Oracle determine the value of multi-block read count, suppose say 128 it comes up with. In this case, the costs are basically the same. The cost of performing a full table scan remains the same. In fact, if you set multi-block read count to 16, optimizer read count will also be set to 16. In this case, the cost actually reduces. So do not meddle with the multi-block read count parameter, because due to the fact that this parameter is indirectly or directly linked to this optimizer read count value, things can get really ugly. And moreover, this will have a profound impact only if the system statistics are not present. If your system statistics are present, then changing this value, changing the value of multi-block read count, even though indirectly it changes this optimizer read count, the costs remain the same because optimizer always uses MBRC value from system statistics. If the system statistics are present, Oracle uses MBRC value from the system statistics. It silently ignores this particular value. So if you do not have system statistics, then don't meddle with the multi-block read count parameter. So indirectly, even though you are lowering the value from 128 to 64, in fact, what you are doing is you are reducing the cost of the full table scan altogether. So don't meddle with this parameter. If the system statistics are not present, this can directly reduce the cost of your full table scan altogether. So multiple Oracle automatically, we know that it will come up with 128 value most of the time. Yes. So this usually translates to 1 MB, guys. So don't assume that 128 is always the case. In certain cases, you will even end up seeing more than 128 value as well. In certain cases, you will even end up seeing a value greater than 128 also. I have seen environments wherein Oracle came up with 136 value as well. So it could be a bug or it could be an unknown behavior, but always remember that 128 is not always the value. It does not always come up with the 128 value. So things get really ugly when you have table spaces with different block sizes. So if your default block size table space, if your default database block size is 8 KB, if your default block size is 8 KB, and if you have a table space with suppose a 16 KB block size, in that case, things can get really ugly in certain scenarios. So we will talk about those in the next subsequent sessions. So next subsequent things. So now these are the basic fundamentals required for performing, regarding a full table scan. So now let me go into the actual stuff. So I have five. I'll do one thing. I'll try to explain next 3 slides, and then we'll wind up, guys. So, due to the fact this is a very first session, and then, sitting for 4 hours, it's already 3.5 hours. So, I'll try to explain few things in the next session. I don't want to continue half and then complete half later. So now, we know that a full table scan or a fast full index scan can be done using direct path read or DB file scattered read. So Oracle can perform a full table scan or a fast full index scan using either a direct path read or DB file scattered read. Direct path read is when you read, your session ends up waiting on direct path read. It means that you are reading the data from your disk directly into your PGA. So it means that you are reading the blocks directly into your PGA itself, not into the buffer cache. So there are cases wherein Oracle will even read the blocks into your buffer cache. Don't just assume that. Yeah, you are in for more surprises in the next session as well. So DB file scattered read means that you are bringing the blocks into your buffer cache, or you can put it as a buffered read operation. Buffered read operation. You are reading the blocks directly into your buffer cache. So Oracle can perform a full table scan using either full table scan or fast full index scan using either direct path read or DB file scattered read. Direct path read is you are reading the data directly into your PGA. Scattered read is you are reading the data into your buffer cache. So now I'll introduce you a small parameter and then we'll wind this session up, guys. So we have a parameter called underscore serial direct read. So let me just take this particular slide here. So I think we'll complete this entire thing in the next session. We can complete this in the next one session itself. The full table scan by Monday we'll complete it all. So serial direct read parameter is, you can think of it as a master switch, guys. So by default, this value is set to auto. Once this value is set to auto, Oracle uses the cost model. So I'll put it in a different sense. Who actually comes up with the decision to perform a full table scan using the direct path read or scattered read? Full table or fast full index scan using direct path read or scattered read. So who, guys? Optimizer? How many of you guys think it's the optimizer?
Yeah, Vishnu, optimizer.
So no, it's
No,
not
it's
the
not.
optimizer, guys.
It's not
It's not
optimizer.
the optimizer. It's the session. It's your session which actually determines that. So it's your session actually decides whether to perform a full table scan or a fast full index scan using direct path reader, DB file scattered read. It's your session, not your optimizer. Optimizer duty is to come up with a plan itself. It's the session which actually decides whether to go with the direct path read or DB file scattered read. So optimizer parent's part is to show the child the right path only. So the child, he can come up with any plans to in a n number of ways to go in that path. So I'll put it in even a more easiest way. So optimizer think of this as just something that guides the session how to do certain activity, but it's the session which actually decides whether to do the activity using a certain approach or not. It's the session which actually decides, not the optimizer. So we'll talk about the cost model in great detail in the next tomorrow's class. I'm just going to show you these aspects as well, and then we'll wind it up. So once you set the serial direct read parameter to never, regardless of the size of the table or the index, Oracle always performs the full table scan or fast full index scan using DB file scattered read only. So I'll just give you a small example. So what I'm going to do is I'm going to create a small table here as well. Create table temp as select start from students where student ID less than, suppose say 1000. Let me show you the students table size case. The size of size of the temp table. We know that serial direct read parameter acts as a. So let me exit. I'm going to flush everything out. I'm going to perform an SQL trace here. So I'm going to set alter session set serial direct read is equal to always. I have set this parameter to always. In this case, regardless of the size of the table, regardless of how many blocks are present in the buffer cache, how many dirty blocks are present in the buffer cache, Oracle always performs the full table scan or fast full index scan using direct path read only. If you set this parameter to always, then your session will always ends up performing the full table scan or fast full index scan using direct path read only. So here the temp table size is only how many, guys? I mean, it's less than 1 MB. It's close to 2 extents only. 2 extents, I believe. 128 KB. 2 extents here. So now let me run a query. Select AVG of smartphone from temp. Let's see the query. So can you notice the direct path read, guys? Everyone? Hello?
Yes, yes.
So if I set this parameter to never, Oracle will always perform the scan regardless of the size of the table. Oracle will always perform the scan using scattered read only or buffered read. In this case, Oracle always brings the blocks into the buffer cache. So this parameter this parameter is very handy in several scenarios when you are creating an index also or rebuilding an index. There are several operations, several places wherein you can manually set this at the session level and then get better performance of your subsequent operations. So I'll discuss this in greater depth in the next subsequent, sessions. So this parameter acts as a master switch case. So setting this parameter to always at the session level, you get several benefits out of it for certain operations. We will discuss regarding that in one session or in a particular when we are dealing with indexes and everything. We will discuss about that. So even for fast full index scans, this parameter is very handy in certain cases. So I'll try to explain that in greater depth. But for now, for today, just remember that if you set this hidden parameter at this session level to always serial direct read to always, regardless of the table size, regardless of all the metrics, Oracle will always perform a full table scan or fast full index scan using direct path read only. If you set this value to never, then Oracle will always use scattered read only or buffered read only. It brings the blocks into your buffer cache. So that's it for today's session, guys. I'm going to stop the recording for now.
Sorry, can we pass